Hey guys, my name is Lakshya and I'm a research analyst at SCALER Academy, and welcome to another video of ours. So in this video, we will be covering everything about debugging production issues. So let's see what you guys are going to learn today. So first of all, you'll start up with debugging production issues, complete question and answers along with back-end versus front-end production issues. Then we'll move on to tools for debugging. After that, we'll move on to which issues are the hardest to debug, and you guys can also tell us about it. And finally, we'll wrap up with how to pinpoint the root cause. And that's about it. And also guys, check out scaler.com where you can join free masterclasses by industry experts. And the link is in the description below. So now, let's start with the video.
Today I got Abhimanyu to talk about some of the operational and human aspect of when things go down in production, and what are the things that teams do to prevent that to happen again, how to do postmortem, all of these things we'll discuss. I think I will start with the first thing is, I think, very interesting. Whenever these somebody joins a backend team in any company after college, back in my college time, seniors used to tell stories about, यार आज मेरी ऑन कॉल पे ड्यूटी है तो बहुत बड़ी बात है, मैं ऑन कॉल पे हूँ. तो व्हाट्स द कांसेप्ट ऑफ ऑन कॉल? व्हाट इज ऑन कॉल and why do we need on call in backend teams?
Right. On call is something which has gone a little, I may say, infamous thing. कि कई बार उस कंपनी को मत ज्वाइन करना, वहां तो ऑन कॉल पे रख देते हैं. तो वन आई वुड मे बी फर्स्ट टॉक अबाउट कि है क्या भाई ऑन कॉल, व्हाई इज इट सो ट्रीटेड, और डज इट इवन नीड टू बी ट्रीटेड, राइट? So on-call essentially is rooted in, it's not a term native to software industry alone. It's a term rooted very deeply into the medical industry for hundreds of years, and actually even the militaries of the world. Which means basically on-call, what that simply means is that if we are having any systems where there has to be someone available at a moment's notice. So for example, जैसे दो countries के बीच में अगर war situation ऐसा है कि अभी war है नहीं, but यार कुछ हो सकता है. So then there are, like, this might be a fun thing to know that ये जो fighter pilots होते हैं वो tarmac पे, like in the advanced air bases, there will be few pilots with their fighter jets engine on, sitting in the cockpit, where they can take off within 30 seconds, right? That if there is, let's say, if the frontier radars detect, let's say, any hostile aircraft entering the space, then within 30 seconds, these aircrafts will be in the air, right? So even these pilots are called on-call, right? That, if there is like from the higher command, if there is an order to get airborne, then like say there can be 5 fighter jets in the air within 30 seconds, right? So it started from the, the defense forces, then in the medical space always that, if there is, like there are ICUs, or let's say there are, critical ICUs. And then the hospitals need that, any patient there can enter a state there, they need to be given CPR, right? There can be an emergency at any point. So there will be some doctors on the call all the time, doctors or the medical emergency staff. That 24/7 there has to be someone who is available within very short span of time, if the requirement be. Of course, as a software engineer, we do not expect कि, रात में 3:30 बजे मुझे कोई call करेगा and within 30 seconds, like a fighter pilot, I have to, be on my laptop and doing something, right? That's not expected. I start my day at 10, I end my day at whatever time I do. But once that's done, one shouldn't keep expectation from me. But of course, then when we talk about any large business, right? Any business which is doing things which is pretty critical, of course, like any company might not be as critical as fighting a war for the country or, saving someone's life. But still, actually, now software, given it is so ingrained in our day-to-day life as well, there actually might be software systems where people's life depend on that, right? Like actually, even if we talk about, let's say, medical systems, the largest hospitals, majority of their things run on certain software, right? And let's say if some of their softwares are cloud hosted, if systems are not working, someone might even die, right? So now if you are at that end, like actually, as they say that, with great power comes great responsibility, right? So now as software has become so powerful, so it also comes with a great responsibility. So let's say, let's take example of Amazon. Now, while Amazon, as a typical software engineer of Amazon, doesn't need to be on such a high alert mode, but someone from the entire tech team has to be on this high alert mode. Where let's say for example, if Amazon's payment things, when you go and make payment, if it starts failing, What that would mean is that as long as it is down, Amazon cannot make any money, right? There will be no revenue for that period from Amazon, right? And which might be surprising, but that might be in the scale of millions per minute and might be even higher. It's hard for me to estimate that. But it might be that if it is down for a minute, Amazon might lose millions of dollars, right? How do companies solve for that? Again, that all the fighter pilots of India, they cannot be sitting in their cockpits all the time, right? That if they need to take off. But they can say that 5 of them can do that at a time. And this is rotating. That let's say today, this person will be on call for 8 hours. And fine, in that entire period, there might be nothing. They might never need to take off. But if they need to, then they are available, right? They will get off duty and some other pilots will then get on call and then they will be available, right? So given now we have large teams, Amazon might have 10,000 engineers. So they might put a small chunk and it will be that, let's say in a month, like of course sitting in a, fighter jet with engine on, it's not easy. It's very hot in there, right? With your entire gear. So, but however, if I ask someone that can you do that once in a month for 8 hours, right? That is something we can do. Fine, in a month, rest of the days I have not that intensive tasks to do. But once in a 8 month, I will be there. That if it is required, I am there. So that is what essentially on call means. No one remains on call forever. It would be more of that once in a week or once in a month you have to be on call. But then it is expected from you that you will have immediate access to your devices. You will be in connectivity. You will always remain in a high speed internet connectivity so that, whatever you need to do, you can deliver on that. And, if there is any alert, you are watching the alerts. If there is any alert, you will be able to act on it. What you will be able to do on that, we cannot say, like, of course, as I said, a fighter pilot who is on call, he might be sitting in his, maybe, we bought Rafale recently, right? So the person might be sitting in a Rafale. If there is any intrusion, he will get on airborne, he will try to defend, but whether he will be able to or not, whether he will call for more reinforcement, we'll see, but at least there is someone who is able to respond to the threat.
Right. Actually, on-call, e-com companies, I think, becomes generally very important in these sale kind of scenarios. So at Target, I used to see there used to be this weekend called CFBM, so Cyber Friday, Black something else.
Black Monday. So,
Black Friday,
actually.
Black Friday, Cyber Monday. Black Friday, Cyber Monday. So, yeah. During that period, I think that weekend used to earn more money than any other particular quarter used to earn. Any quarter would not earn money as much as that weekend used to earn. And that time, I think we used to have a bigger on-call team. Generally, there are 3-4 people on call, but during that time, there used to be like every team had to dedicate one person for on-call, like any component if it fails. Because at that time, every 15 minutes, $1 billion revenue is getting made. If anything fails, then it's a big difficulty for people. So
this is also, I think I can relate that with again, the defense things that, for example, in the Indian Air Force, probably there will be, even if there is no skirmishes, there might be just maybe 1-2 fighter pilots on call that then, on command, they can get airborne in 30 seconds. When there are heightened tensions, or let's say if there is some geopolitical instability, then there might be much larger volume of fighter pilots on call because they perceive that there can be a bigger offensive at any point in time, right? So same as that on a Cyber Monday, on a Black Friday, on a Cyber Monday, etc. Now this might be new for our audiences, but this is, you may say, this is similar to, let's say, pre-Diwali sale of Flipkart in US and the western parts of the world.
Big Billion Day and Amazon Festival, all that stuff happens.
Right. So in US or in Europe, just before the Christmas, people get on a shopping spree, and then there is this Black Friday where there are very heavy discounts on everything, and then people just go crazy buying.
Right. So next question is that obviously a lot of people get on-call duty, and I have been on a lot of on-call duties. I have never actually had to face any incident. So on-call is like, अच्छा चलो ठीक है रात को आज जागना है on-call है. But now in that unfortunate situation where you are on-call and something actually goes down, then as a level-headed person, how do you go about, like, what are the steps we should follow? What should we keep in mind?
Right. Yeah, actually, that is one, as they say, again, I'm feeling that I'm giving too many references to, armed forces here. But I think in this situation, this on-call or, production down situation, a lot of things relate very well with that. that one of the core, very important quality to possess is being able to perform with the same efficiency or, very, very high efficiency, even under the situation of extreme pressure, right? Where, there is a lot at stake. That, right actions at this moment, even every single moment, every single second, every single minute has extremely high value. Right actions might lead to huge value, and at the same time wrong actions might also lead to extreme amount of damage to the organization that you have, be it reputation, be it revenue, anything. But these are such environments, right? And of course, very candidly, it's not everyone is not cut for that. However, as they often say, that true leaders are tested in the toughest times, right? In the peacetime, of course, it's hard to know who is the best, general of the army. When there's peacetime, you cannot say, right? But who were the best generals of the army gets tested in the hardest of the time. So in such situations, the same thing happens, that the best leaders get tested in such time. I think one of the most important thing, when in such situations is being calm, right? Being able to have this bigger picture that, there is a situation, there is something that has gone down. Of course, if something has gone down, something in the past was not perfect, right?
Right.
But right now, like priority of thinking, it's very important. Like, prioritizations of what should be done at this point in time is one of the most important skill to possess, to kind of, be a hero in such situations, right? And not a person who actually further damaged it. Which is, what is the prioritization? Now, let's say something is broken. Is my priority figuring out that why did it break, or, who broke it, or, starting the blame that, this person did this, that is why this happened? No, that is not supposed to be the priority. This is still a good, valuable thing to do in a right way at a different time, so that it doesn't happen again, right? But at this moment, the priority has to be what is broken and how we can make it less broken, if not perfectly fixed, right? Even that is high value, right? Let's say if 100% of the orders are not getting through, let's say in an e-commerce company, let's say you are Amazon, you are in leadership, or you are an engineer at Amazon, and it's a Cyber Monday, or let's say it's pre-Diwali sale, and the systems have gone down. 100% of the orders are not going through, and that within 5 minutes you can do something which will make sure that 70% of orders start getting through. Even that is great, right? And then you can tell that, all right, here is another thing that, like here are the patches which could be done in another 30 minutes, which will make sure 100% of the orders start getting through, right? Now, the third priority would be that, then when it's all over, we know that, lives have been saved. Then we figure out that exactly what are the series of events which led to this. And then, like, this could also be done 1 week afterwards, right? This can also be done 1 week afterwards, So I think that is one, like, often people fall into this. Some of people who are in the audience might have been in the situation where, the person who is leading is kind of panicking and asking, who did this, who did that, and, why did you do this? That is absolutely the worst kind of thing. Like, if you are seeing this, actually, even if you are a junior person, it might be a lot of value to just, calm down the environment. That, all right, we will get to that. Right now, priority is fixing this. Let's talk about how do we improve the situation here. And even putting it out there, like, one thing that I do believe is that you can do that even if you're an intern. Trust me, like, that is one very beautiful thing about the, good product companies and the world of technology. That even as an intern, if you put it across, that, all right, here is what is broken. Here is what we are trying to achieve in next 15 minutes. Do everyone agree to that? Even if it might be, your engineering manager with 15 years of experience. And if they say that, yes, this is what we agree to, and what caused this, what series of events led to this, we will look at that maybe after 1 hour, once we have addressed this. All right. So even if you are an intern, like, have the confidence to say the right things and get things back on track. If you see that, and of course, as a leader, it is your job. You cannot consider yourself a leader if you are not able to prioritize things properly, and if you are not able to focus on the things which are most important right now. Being calm, being more mindful, that what am I thinking, what am I acting, what am I saying, and are all these things going to improve the situation in the most quick way and in the most outcome driven way. That is something I think that every leader has to be mindful of. And if you feel like, actually, trust me, it's very natural. Let's say as a founder, I'm founder of a company, or I am the, let's say, head of engineering for a company, where I know that every single minute millions of dollars are being lost. It is very natural, it is human to get agitated in that situation. But instead of, if you know that you are agitated, instead of jumping into things, right, then it is okay to take 2 minutes to calm yourself down, 5 minutes to calm yourself down, put your thoughts, have clarity of thoughts that what you want to execute, and then get onto things, right? Those 2 minutes are not wasted. Those 2 minutes might create a lot of value.
Right. Then the next thing I would like to talk about, which is actually title of today's talk as well, is about war rooms. So a lot of scenarios I have seen war rooms getting formed. So it might not. Sometimes it's like on call you find out some error and then okay we have to fix it. Maybe you put a patch and then you have to properly fix it next 2-3 days. Another kind of scenario I have seen. So at Zomato we were using some order IDs with an integer and we were about to run out. So then a war room was created that okay within 1 week we have to change everything to strings everywhere because at the current volume we were doing and the volume was growing also, within a month it will all turn into, it will overflow integer. So before that you have to make sure. So sometimes like there is 1 month long war room also, but sometimes 1 week long war room that okay we have patched something right now, but let's figure a proper solution. So what's the situation? What's the atmosphere in a war room? You might have been in war rooms also before. So what's the mindset? What's the pressure? And what good practices you must follow when you are in a team which is working in a high pressure scenario for 1 week at a time or something like that?
Right. Yeah, actually, it's a very, I think, not everyone gets to experience that, but those who do, I would say they are all very, very lucky, because as they say that the best war stories are written in the trenches, right? These are the times which kind of you learn a lot as well, and like amazing memories, a different kind of adrenaline rush, right? So that all is there. I think, however, at the same time, it needs a lot of great leadership and level-headedness to be able to execute under pressure, right? So some of the things that I see that which must be avoided as the highest priority is, which is that under pressure, often some people end up doing things which are, there is a word, a funny word for it as well. I'm not able to recall that right now, but which essentially mean, like something similar to, let's say, cascading failure. That, under pressure, you are doing things which are causing further damage than actually improving anything, right? Just because
compounding
you don't know what you are doing. Compounding the issue, right? So most important thing is just try to make sure that you are not furthering the damage, right? It's okay to kind of say that this is fine, this can remain as it is, we don't know how to improve this, so we are not going to touch this, and whatever we are doing, we'll do it in a way which definitely doesn't cause any further damage. Data loss prevention, which is like again, you must make sure that, which is kind of a sub part of preventing any further damage, that you do not make any changes which cause certain data damage, right? Because its data is gold. It is the for any tech company, data is what we all live on, right? So you cannot lose that. Imagine if let's say if Amazon loses all the past data, then Amazon probably as a business would vanish, right? They will not have any upper hand over any other company, because they know about me. They know that what I buy, what I do not buy. That is why they are able to get me to buy more, right? They are able to take out of decisions basis, data of millions of or billions of people that they have. So ensuring that you are not doing anything which will lead to further data loss, or if there is data being lost already, then first thing you have to do is that you have to kind of prevent that, right? Another important thing is that often, again, in the stress environment, it is possible that we start doing too many things, that do this, and then when we are trying to run it, we do not know what is the difference what thing is making, and then like I have changed 10 variables at the same time, and then I do not know that which of them are actually improving, which of them are not improving but rather degrading. I only know net, right? So another right way to do it is that change one thing at a time, see that whether that change is doing the improvement that you intended from it or not, right? Do not get into, do not get overwhelmed and start doing 10 things at a time. Even if it is a team, as a team as well, I think it is important to compartmentalize. And, let's say when there are 5 or 7 people trying to do some things together. So you compartmentalize, you tell them that you are only doing this, I am only doing this, and these two are sandbox. So we know that how they are working, right? So doing one thing at a time is also super important. Another one is that, one should document this. I have had personal experience of a counter case that, the system was down, 2-3 guys, in the war room, they did bunch of stuff, and it is working right now. And when they were asked, what did you do? Can you tell us that what all have you done? After which it is working. Because, can it go down again? Because, it is magically working, but the core issue might still not be fixed. It is working maybe because there is lesser traffic right now. And the moment traffic comes back again, it will go down again. And they were able, we don't know. We were just trying out a bunch of things. We had run some 20-30 commands and it just started working, right? So this is a very bad state to be in, right? That let's say your system was down, suddenly it came up and bunch of people were doing certain things, but they do not know what all they have done. There's no trail of that, right? What all they have changed, what all commands they have run, right? And then it's a worst situation to be in because you do not know what is working is going to continue working or it will crumble down again, right? So it is very, very important that you document every single thing that you are doing. When you are in the war room, it is super, super important that you are documenting every single thing you are doing so that you might be doing a lot of experimentations. You might be trying out things. That happens in the war rooms all the time, right? That we just, let's say I see that system is down, the monitoring is in place, but let's say some of the variables we are not able to monitor. I will say, let's just try to increase the, let's say, RAM of all our servers. And maybe that works, right? Maybe it is, it is all in a deadlock because the RAM is low, right? But I should document that. I have tried increasing RAM. After that, these were the system monitoring readings, right? So whatever changes you are making, or I might say that, I'm gonna, let's say, increase the U limit, right? So like in any Linux operating system, there is a limit set that how many parallel network connection a machine can open, right? And that might be the bottleneck, right? One might say that because my U limit, which is the number of parallel network connection, is set to, let's say, just 32 or 64. So that is why my system is, kind of overwhelmed. So maybe I may say that I have enough RAM. I can say that my U limit can be, 256 instead of, 32. And that might just make everything work. It is all clogged on the network. If I make that wider, then, it will start working. But again, if I'm changing U limit, I should document that across all the servers, I have changed U limit from 32 to 264. And whether that worked, whether that didn't work. After that, right after that, there might be some consequence that, you changed the U limit and then suddenly your RAM users have spiked, right? But documenting is super, super important. Keep documenting every single thing you are doing. What observations? This is again, those of you who might have seen Chernobyl.
Yes.
Right. So, like in nuclear reactors, for example, if you are trying some things out, the assistants were insisting that, let's follow the manual. Let's keep documenting everything we are doing. And the boss, of course, said forget it. I'm saying just do it. And that is a disaster. That actually, this simple thing, not following documentation and not documenting things you are doing might even lead to, disasters like Chernobyl. Fortunately, of course, there are even software systems at nuclear power plants as well. So, if someone is kind of, in the war room, actually, there might be a software engineer who might be fighting a war room story in a nuclear power plant as well, right? So it is equally, it's harder to imagine and perceive, right? But there might be software systems which might lead to a disaster like Chernobyl as well. And there might be, even maybe any software engineer can end up in that situation, right? So it is important that you follow the documentation, that what all have been done before, you document what you are doing so that better decisions can be taken every single moment right after your actions as well. That's, I think, super, super important.
I think the takeaway is actually not to give up the basic scientific principle that when you change one thing at a time and then you document what was changed and what was the effect. Then you change the next thing. I mean, whatever is the pressure, but that principle should not be, that's not negotiable.
Right.
So that's
on that, actually, trust me on this, that do not leave the scientific method, even if there is anyone sitting on top of your head and continuously shouting, why are you so slow? Why are you so slow? Don't leave the scientific method. On this, I have a very funny anecdote. One of my ex-colleague, and like back then, the project we were working on, and the person who was on top of all of us, you may call it the CTO or someone, he said this guy was like, we used to make fun of him, that this guy is so cool that even if the CTO is sitting on his head and shouting, he will just calmly be on his laptop, and if he's asking that, what are you doing, he will just say, I am reading the logs. That, like very calmly, dude, I am not gonna run 50 random commands that you might be insisting just go ahead and run. I will follow the systematic process because I know that is what is going to lead us to right outcome. That is the fastest way to restore the systems. Just doing random things, just trying out random things without understanding what they do, what that might lead to, can only end up in even worse situation than making anything better. So even, being able to remain calm and stick to the systematic process of fixing things is, I think, super, super important, no matter what people might be shouting, no matter, and it's natural. Understand this, that when there's a war, when there are bullets flying, there will be some people who will panic. That's natural. But a good leader, despite people panicking, they will be able to hold the grounds, plan out a strategy out of the situation, and lead people out of it.
Makes sense. Next, we have, I asked some people who have been in war rooms and on call, and I asked them what are some of the common terms. So I asked across like people in the community and friends, and I got a list of terms. I would like to, go through some quick explanations on them for people who have never been in a situation they might have not come across these terms. So what are these and what do they mean? They are very fancy sounding terms. I think first one is kill switch. What is a kill switch for? What is the purpose?
Right. Yeah, kill switch, of course, the name, it's always self-explanatory. So again, let me give a analogy from the front lines, war front lines, right? Now, let's say you have a bunch of, you may call them your armory or your soldiers, and there's a new kind of armory, that you want to deploy, right? But that, it's not really tested. We are in Second World War. There is a lot of machines that we are trying to deploy that, might might not perform as we expect them, right? So I would want to have, a way to kill them if they are kind of counterproductive to, what I want, right? So this is something that companies do, that let's say if there is a new aggressive feature that we want to roll out, and it is very hard to, fully test it in the production environment, right? And there are certain risks that it might affect the system negatively. So let's say it got deployed, and right after that we noticed that, it is maybe high probability that it might be because of this new thing that we deployed, right? So now what are our options? Our option might be that, now let's revert back all the changes that were done for this feature. Now that is going to take a lot of time. That cannot be done in 30 seconds. So while developing the feature itself, companies keep a kill switch that, let's say, this entire feature will get deactivated if there is a certain record set in the database, right? That the moment, let's say there could be a simple product feature name and true or false against it. This entire feature will work or be on production and only if this flag is set to true. If I make it false, it is as good as this entire code not existing, right? So this has to be, however, part of the development. If something is built, then you cannot suddenly inject a kill switch.
Precaution measure,
right?
Basically.
It's a precaution measure when you are developing the feature itself, right? So companies do that. Any experienced, seasoned leader, if they see that there is a possibility of this affecting anything negatively once it goes to the production, so in the development itself, we will say that let's have a kill switch, so that when we put it on production, after 5 minutes, if something is going wrong, production went down, we will just change this to false, and this will be pulled out. Then fine, our feature will not be on production anymore, but no one can tell us that we took the system down, right? So that is what a kill switch is. If you ever feel, if you are developing anything where you see any risks, then you should definitely try to incorporate a kill switch, and then kill switch can be removed over time. Let's say if it went on production, and then for quite some time we know that it is fairly stable, and it is additional code baggage that we have, we know that this kill switch is never needed. then fine, like in future refactoring, the kill switch can be removed, or it can be kept as well, that no harm, that it is, if there's no additional overhead, it can be kept forever. But yes, that is what kill switches are about.
Right. Right. At Zomato also, we used to try out actually kill switches before December, because that's when peak used to happen,
Right.
like, that 25th December, 31st, that period, maximum orders.
Right.
So, you should test out things like if, say, review service is down. So, we can turn off reviews, and still people, like when they search restaurants, they will see listing, but they will not see the review of items, but it will continue to work. Because generally, if review service is down, then it brings down the menu service as well, because menu has to query the review to show that review thing. But we need to have a feature to disable reviews whenever you want to. It's interesting.
Right.
Another term I think gets thrown around a lot in war room scenarios: database rollback. So how helpful is that? Is it something commonly used?
Yeah. No, so database rollback, again, the term itself is self-explanatory, that most of the times, of course, as we mentioned, that most of the larger systems, they're all on top of data is their blood, right? They are just working on top of data. So when we are saying that data is the blood, and then any new feature might change the schema, might create new records, might kind of have certain structural change to the database, right? Now, what if that this new feature caused big change to data? And now that is what is causing a lot of issues, right? How do you change that? Now, let's say, like a simple, more concrete example. Let's say to build my new feature, I changed schema of certain tables, right? But I was a very shabby developer, and I didn't realize that the same tables, schema, etc. is also being used by a lot of other features, right? And I just pushed it in. Now, like all those services which were using the older schema, which were not refactored, they're down now. Now, of course, my one option could be now go and change all those other features, right? Which is, of course, is not possible in 30 seconds or maybe even 10 minutes or even in hours. It might take weeks or months to do that, right? So my only option then is that, again, I do the kill switch on my feature that is stopped. And then I also have to revert the database back to where it was, so that other things can continue working, right? So that is generally when the database rollback come into the play. Fortunately, most of the modern databases provide a very smooth way to do that. Like, be it MySQL, be it, Postgres, etc. There's always a way where you can kind of, basically your database is not just, a snap in time. You can have snapshots of the databases taken at an interval, right? Or, there are a lot of, whatever commands have been run, you can kind of run the reverse commands and revert back all the changes that have been done to whichever state you want to go, right? So that is what database rollback does. Of course, in the process of database rollbacks, there is always a possibility of losing some data. Now, let's say, certain database changes were done, and then it was live for 10-15 minutes, and certain additional data was collected in this time, and then you are doing a database rollback. So that might lead to, whatever data was collected in 10, 15, 30 minutes, you might end up losing that. But then there is a vetting need to be done, that what is better? Is it okay to lose 10 minutes of data? Might be, a few hundreds or few thousands of the records, but we ensure that all the systems go back, become stable. Or you might take a snapshot of this database right now and then immediately roll back, so that you do not really lose it. It might be lost in the data that is in production, but the actions in this time are also stored in the snapshot that you have taken. And you might see that, if you want to kind of refactor them and put them back in the database. But yeah, data, that is how database rollbacks work. Might not be the best strategy all the times. You will have to vet out that whether doing the rollback gives us more value, or not doing the rollback gives us more value.
Right. And that also means when we are choosing databases, the ability to do rollback is also an important factor to consider.
Yes, absolutely. Because when you are building the software on that day, it might not be a consideration at all. But now, let's say you are a multi-billion-dollar company, and then you are at a stage where every single second you are losing millions of dollars, and whether your database supports rollback or not might lead to, at that point in time, it might be, very, very important consideration. Again, this is where I think, experience and, knowledge comes into the play of the leaders, that, they would be able to say that this is not something that we might need now. We might not even need it for next 6 months or a year, but we might need it when we, 2 years down the line, and it might be a very expensive issue to have if our database doesn't support rollbacks, and to what extent it supports rollback, right?
Right. Then, apart from data, similar term I think gets thrown around for the code base itself. A lot of times, security says, just check out last commit and try to see.
Right.
What does that mean? Does that work well or not? Yeah.
Right. No, so actually, even binary search, which is often an algorithm that we use for the fundamental data structure algorithm problems. But, even applying binary search on commits is also a very powerful tool. So basically now, let's say suddenly you realized that my systems have gone down, right? Now it cannot happen without any input, right? There has to be something that changes somewhere. That is when things start breaking, right? So check out last commit would be the obvious one. That let's see, just before things went down, what was the change made to our code running on the production? Let's see that. Is there something that might have caused it? It might not be, maybe nothing in the last commit caused it, but there is a high probability that whatever is the last code added to the code base is what caused it, right? Now there might be an intern who just, he didn't know his stuff and, just wrote some fancy code and, that got put into the production without much proper review. Or it might be, a new feature who was pushed by the most elite tech team of the company, which is causing that. It could be anything, right? But seeing that what was the last thing, and even then, like often there's another thing that the last push might have 20 commits in it, right? There might be a PR which just got merged, but there were way too many commits to it, right? So again, doing a binary search amongst all of them, that we know that in this deployment, there were these 60 commits which went in. Which of them might have caused it? We don't know, but quickly you can do a binary search on them. Let's start with the first, the last commit, right? Is it causing that? If I just revert that, is the systems coming back in? No. Let's try the last one. Is system coming back in? No. Then let's try the middle one. And then within just 3-4 iterations, we would know exactly which code line caused it. So that is about, kind of going through the last commit and figuring out what might have caused the issue.
Right. Bisecting the Git history, basically.
Bisecting the Git history, basically. And then, instead you might just be trying everything and that might take a lot of time. And this way, just 2-3 iterations, you will land up to which might have caused it. And it could also be done on your local machine, right? You do not need to deploy everything on production, but you can just do it in your local machine. Within 5 minutes, you would know that exactly which commit caused the issue.
Right. Actually, my experience is like when I have been on call, this is very important because I don't always have context of all the code that was written in the last, say, 1 month or something. So I have to go by the commits and then I will find the faulty commit and then I will read that code and understand, okay, what happened. Right. Otherwise, I don't have understanding of the entire code. 30 people are writing code. Every 30 commits are coming in.
Right. So I think one important thing is that good leaders know that they are not Superman. No one is Superman, right? One might say that, no, I'm not going to do this. I'm going to read the code in detail and then I will figure out what is going wrong. So, understand that you are not Superman. You cannot read thousands of lines of code within few minutes and understand that what is going on. It's okay. I don't know. It's a black box thing. I don't know what is going on. I will just try out which commits make system work, which commits do not make system work. And when I have zeroed down that this was the commit which might be 100 lines of code or 50 lines of code, after which system doesn't work and before the system works, then I will probably just go and read those 50 lines and try to maybe get my head around it, or maybe try to get inputs from someone who might know that better. But understanding, do not try to be a Superman when the systems are down.
Correct. Then there is another term often gets used is like, as a mechanism for recovery is like, let's throttle our request. So what does that mean when we are saying this? Yeah.
So throttle basically, is essentially, it's also a word in the vehicles as well, right? That throttle, and it like as an English word, it means that to reduce the speed of engine, right? By closing the throttle, that is what it means. That throttle, basically what throttle in automobile does is, it's a part in any automobile. What it does is that, when you press it or when you reduce the intake, it essentially reduces the intake of the fuel to the engine, which is definitely going to lead to slower throughput from the engine, right? Exactly same thing in the tech world as well, that if your backend systems are the engine, and let's say the request being sent to them or the load being sent to them is kind of, what pushes them to, the outcome that we expect from them, you can reduce that, right? You can say that, these shouldn't be sent at this rapid speed. We are able to see that our systems are not able to serve to that. So let's throttle that. What that means is that, let's say I may say that right now my servers are experiencing RPM of say 1000 requests per minute, right? My servers are experiencing 1000 requests per minute, and I'm able to see that the systems are not able to handle that. So what I can do is that I can, like, if there is any way I have to kind of throttle that, to say that let's reduce the speed. Let's say I might just simply say that from the clients, from where I am getting too many requests, I'll put a captcha on them, which will force them to reduce the speed at which they are, kind of sending the request. Some of you might have sent a captcha popping up on Google search, that you are doing a Google search and then it shows a captcha, which is in a way also Google is throttling the request. They feel that there are very high volume of searches coming from your side, which they do not see as natural, which might lead to system degradation on their end. So they will say solve this captcha first and then they will let you search. Right? So this is essentially different ways of throttling the request. And then of course in the later tiers, there can be ways of purely technical way of throttling the request. If you know that one of my services is calling another service and this call is happening at a very high rate, then you can just say that let's reduce it. And that might get our systems back up.
Right. Actually, very interestingly, I mean, these days, even these cloud providers like AWS, etc., they sometimes come with out-of-the-box throttling, debouncing services in the load balancer itself. Like you just install a load balancer with throttle service available, so you turn on, turn off throttle automatically. Very useful. And then finally, very common term gets talked about a lot. So sometimes, techies are discussing that, we are under a distributed denial of service attack. So what essentially does a denial of service attack mean? And, what can you do to also recover from something like this?
Yeah. So DOS, in the technical words, its acronym is DOS, right? Denial of service. Or DDoS, which is distributed denial of service. So DOS is simply denial of service attack is that, of course, there are shitty people in the world who making other stuff break rather than building something. But of course, we have to admit what the world is and thrive in that. So often there are, people who might launch a denial of service attack on your services, right? Which simply means, what does denial of services mean? That let's say if you have a shop and you know that their shop can only cater to 10 customers at a time. You only have, let's say, 4 or 5 shop assistants. They can cater to 10 customers at a time. Now, let's say there was a weird person who says, I want to make sure कि इस बंदे की दुकान से कुछ नहीं बिके. So what he can do is, he can start sending thousands of fake customers to your shop every hour. What they will do is they will come, they will just waste time of your shopping assistants and not buy anything. They will waste their 10 minutes and then go, right? They will not buy anything. So the real customers who are trying to come to your shop, they will see a huge line in front of your shop. They might wait for some time and then they will leave, right? That, maybe I'll buy from the next shop. So effectively, the real customers are not able to buy from your shop because there's a huge queue created in front of your shop. And, people who are actually queuing up, they are not really people you want at your shop. They are just, they are random people. So how could one do that for your online services? Right? Now, let's take example of InterviewBit. Now, there are genuine people, or let's say SCALER, that there are genuine people who want to come, learn, and do stuff here, right? Now, let's say, and we know that our systems are capable to serve 10,000 or 100,000 live users at the same time. There can be 100,000 people studying at the same time using InterviewBit, and our servers will work fine. We know that it is very hard in India, even if there are, let's say, 10 lakhs or 20 lakhs students, at a time only 1 or 2 lakhs will want to study parallelly. So our systems are capable of that. So we have only built systems in a way where that can be catered, right? Now, let's say there's a shitty person and he starts sending a lot of fake requests. There are a lot of fake requests that are being sent, right? Which exceeds, 1 lakh requests that we can handle, right? So naturally, when the genuine person comes, then the site might be down. It might say that, site is not opening. It is just forever loading, right? So that is just denial of service. Now, to create that volume of requests, it is very hard for one to create this volume of requests from one computer, right? So what these, hackers, or, I would rather call them not hackers, but shitty people, they do is that they will create a botnet. Like often you might install certain browser on your browser. You might install some plugin or extension on your browser, or you might install some app on your mobile, which might not be actually genuine apps. these hacking applications created by these people who operate botnets. And these applications might start sending, let's say now I am a person, I am a black hat hacker, and I just do shitty stuff to earn money, and let's say there is someone who want me to take Zomato down. I am, let's say, for whatever reason I want to take Zomato down. I paid money to this bad person. He has botnet created. He has created some shitty mobile application that he got installed into mobiles of 10 million people. And from his computer, he can say that all those mobile phones start sending requests to Zomato.com. When that is happening, so there will be so many fake requests going to Zomato or InterviewBait from these people who don't even know that their phones are sending these requests, right? And this is distributed in out of service, because now there is no users. It is very hard to identify that these requests are coming from so many different IPs that even for InterviewBait it is hard to know which are genuine, which are not genuine, right? Because even people from whose mobiles or browsers these requests are coming, they themselves not know that these requests are being sent from their devices. They might be very well genuine users as well, right? So it gets even harder to kind of tackle them. But again, throttling, the point we were talking about earlier, throttling helps with that. That if there are requests coming at a very high volume from a single IP, like for example in InterviewBait as well, we have that if you start sending request above a certain rate, which we know cannot be a genuine user, then automatically it will present you a captcha. That fill this captcha, only then I'm going to serve future request of yours.
Correct,
right?
correct.
So then that way DDoS can be avoided. Yeah. So that prove to me that you are a human, and if you prove to me you are a human, only then I will let you access my services now onwards. Now, of course, there's another bad, flip side to that often in colleges, campuses, institutional campuses, often what happens is that everyone in the college is behind a proxy. What proxy means is that there's a singular IP to the outside world, and everyone in the college is behind that singular IP, right? So to InterviewBait, it will seem like that all these high volume of requests, which are all genuine requests, are coming from one single IP, right? Which is the IP of that college campus. So then there are also ways to kind of handle that. That of course you can create, let's say for example at InterviewBait, we kind of whitelisted that these are, let's say, set of 50 IPs. We know these are the campus IPs of these most popular, biggest campuses in India. And we are not going to throttle requests coming from these colleges. At least, or we can say that the throttle limits are going to be much higher if the requests are coming from these places. But if we see very high rate of requests coming from any other IP, then there will be a throttle deployed, which is, prove yourself that a human, and then only you can use the services.
Yeah. That college thing, we also used to face similar thing whenever we used to had some competition or something, and the competition would stop working because their IP would get blacklisted very early because all the requests coming in from same campus LAN network.
Right.
Before I actually move to other questions, I have a few more, but there was a very interesting question that came up on the chat. So, and I feel it's a super important question to answer to yourself as a techie as well. If in your tech team you are the only one who is always solving the problems, then what's the path to growth?
There is not, like, of course, we all as a human, we all learn from people around us. There is always a lot to learn from people around us, right? But even if you do not have, if you are the only one, in the team, that's okay, because, as there is this concept of first place, second place, third place, right? That your office might be the place where you can be surrounded by people and learn from them. But even if not, there are various online communities that you can be part of. Like, to be very candid, we are very proud of the SCALER community, where, people might not have the most inspiring people around them at work, but in the SCALER communities, they thrive. They are able to have great conversations, great discussions. So getting involved with, like internet is a superpower, of course. And what it has done is that it has kind of made the entire, ecosystem an open field. We can get connected to the, most inspiring people. For example, like I do believe that here we are able to converse. So I think getting involved in even online communities, the right kind of online communities where, there are people with the right kind of experience, aspirations, etc. It does help a lot. It's not necessary that you have to be, it has to come from work itself. Sometimes it comes from work. It might come from the friend circle. It might come from the communities that you are part of.
Right. Community is obviously very important where you learn from. Coming back to another question. So, this again, after the war room is sort of the solution is found out, war room is closed down, then RCA documents are created everywhere, root cause analysis documents, and I heard most companies follow. I think this is Six Sigma, and all operational companies have this principle like 5 whys you should ask to create an RCA. So, what are generally practices that are followed, and why do we need an RCA? So, anything you can shed light on?
Right. So as we were talking earlier, that RCA is essentially root cause analysis, right? What caused it. When things broke, of course, if there was for example, let's take an example of Kargil, right? That Kargil thing happened. We realized that there are people who have entered our territory, and now we have to repel them. At that moment, of course, the focus was on how do we repel them. We claim back our territory, right? However, the second thing would also be, which generally is not that glamorous, and we don't hear about that much. I'm sure that our National Security Agency then would have figured out that what caused people to enter our territory at the first place, right? And then we had to work so hard to repel them, right? So at the first place, ideal would be, but that is not the question at that moment. At that moment, of course, the thing is that you repel them, but then the RCA is going to unearth the thing that what were the lapses in our processes which allowed people to enter our territory and then remain undetected for 6 months, right? So that is essentially what RCA is. Let's say system went down. At that moment in the war room, it's gonna be that how do we get them back up? That's all. But once that is done, then we also do not want that we keep fighting this war every year, right? So then we are going to figure out that what was the root cause of this being happening. So companies also, all the good tier 1 product companies, they follow a very structured process for that. They will create a document out of it. They will figure out that what were the things, what were the series of events. And often these series of events are also, it's a science in itself. It's very, very complicated. The series of events, there is something called as butterfly effect in physics, right? Where like basically what butterfly effect mean is that even a butterfly flapping its wings might cause a cyclone in some different part of the world because of the cascading effects, right? So even in the software system, such things are possible. That something which doesn't look like a cause of what happened naturally, but when you go in detail, when you start following the trail, then you realize that some very small minor things done, very unintentional, very innocent things done many months back might have caused it, right? So that is what RCA do. 5-level why, that you do not just put it on this, but let's say when you are, the first question would be that this is also a psychological structure framework, that when you are trying to find root cause of something, you have to ask why at least 5 times, right? That let's say if I say that why did the system go down, then there would be one answer. That like let's say databases went down, that is why system went down. Then my question would be, why did databases go down? Then might be all right. The number of requests coming to the database was too high, which was more than what databases could handle. That is why it went down. Then I would say that why did the number of requests coming to the database went so high suddenly when earlier they were never high. So basically, at least asking why 5 times will get you to the real root cause, right? So that is what we do in the root cause analysis. Exceptionally important thing that, of course, the system might have gone down. You might have immediately within 10 minutes, 30 minutes, you might have gotten it back up. But you do not want it happening every day, right? You do not want fighting that war every day. Right? Similarly, let's say there were people who entered Kargil, our forces repelled them back, but we do not want that happening every single year, right? So then we will do the root cause analysis, and like for example, defense forces, then they ensure that there is fencing done across the border, there are floodlights installed across the borders, there are sensors installed across the borders, that even if we are not patrolling those areas in the peacetime, even then if there is any movement that gets reported, and then that can be tracked and that can be repelled before it leads to these kind of things, right? So that is what root cause analysis is about.
Right. And it's very, I think, valuable, these documents, because in bigger teams, mostly part of onboarding also is you have to read some of the older RCAs in many companies. I've seen this, that, whenever you work on a new system, you read, these are 5 last RCAs, please read that. And that's important to have that context for everybody working on that system. It becomes part of knowledge base.
Right.
Then we have this question, which is I have been seeing recently, actually, as the work culture everywhere, tech across everything is improving. SRE roles, DevOps roles these days, they generally have this in perks of the work that we have blameless post-mortem culture. And on Twitter, etc., also people post like, can you recommend companies which have a blameless post-mortem culture? So what is this blameless post-mortem culture? Why there is so much focus on it? Why is it important?
Right. No, so this is also an important, mindset shift, or the belief shift, that the purpose of RCA or postmortem is not finding the culprit and hanging him. That's not the purpose at all. It's nature of the doing anything big, that things might break at one point in time. And the nature of this is, as Jeff Bezos say at Amazon, that it's always day one, right? That we never say that we have arrived. We always behave like a young kid trying to struggle to build something, right? So things are going to break. That is part and parcel of doing big things, right? When someone is making something big, some things will break. What is important is that whenever something breaks, we learn from it. And it's not about blaming. It's not about someone like, even the best coder in the team, even the founder of the company who is a coder might make a mistake and it might lead to things breaking, right?
Correct.
The reason is that we learn from it. The purpose of postmortem is not firing someone, not at all. So actually, even when you are working in an organization, if you are confident that you are in an organization with the right culture, like even if you know that there is something that you did that might have caused it, do not hesitate about putting it forth as quickly as you figure it out. Never try to hide it, because in any company with good culture, you will never be hanged for it. Rather, you will be probably rewarded for the fact that you are able to come up with that, this is what I did and this might have caused this issue. Let's make sure that everyone knows that in future we shouldn't do this, right? So as a part of a fast moving team of capable people, everything you do it with best of your intent, even if something goes wrong because of that. There is a value that can be created out of that, which is the learning that this thing cannot happen ever again. Right? So never try to hide, because it's as we say that it's blameless post-mortem, right? I can share my personal story here. I think this was 2012, and we basically had like now, of course, AWS has a lot of indexing services, but back then I think AWS didn't have that. So we had our own cluster of servers running SCALER. SCALER is basically an indexing service, and I was doing some stuff around that. And for whatever reason, what I did was that what was the data in my local machine, I copied that over into the production system. Not the database, but the index server of SCALER, right? What that led to was that on production, in a particular section, on production, what was visible was the dummy data from my laptop, right? Which is, of course, very stupid thing to do. But yeah, I did that. I until unless we break some things on production, we are not true engineers. And then it was like across the world, in our New York office, Pune office, Berlin office, everyone bells are ringing. That this, what are we seeing on production? Why suddenly this content which doesn't look like, which is kind of placeholder content for text, dummy images, why are they surfacing on production, right? Which have very absurd sales price. So there might be, let's say, a photo of bunny which is being sold for $100,000 on the website. But then immediately while I was not even part of the team which handles SCALER, and I saw that this is happening. And then, like in the common group, I quickly typed that, guys, I had just run a script on my local machine related to SCALER. Might be related. I cannot be sure it does. I am not able to connect the dots that how me running something on my laptop might cause this, right? But then with that, we were able to fix that within 5 minutes, because if I had not spoken that out, then the production would have remained in a bad state for many hours, right? Or if I had tried that, let me try to cover my tracks, right? And then as an RCA, when we did RCA of that as well, I was part of the team which was then working on the RCA of that. Of course, I did it, so I'm supposed to be part of the team. Then it was very clear that the production credentials shouldn't be in the code base. Like it happened because the production credentials were in the code base that we were checking out. It was on my local machine. When I ran the command, there was just one command which was missing, like one parameter to the command which was missing, and it defaulted to the production credentials and pushed all the data there, right? Like because I was upfront about telling that this is how it happened, and there was no blame. The issue was not me running the command on my laptop. The issue was the credentials being there in the in the code base. The production credentials shouldn't be in the code base, right? Which is a big security hole as well. So yeah, this is about blameless post-mortem. That like we all have to, like, this has to be a culture. And if you see it happening again, I would say, no matter where you are, even if you are the director of engineering or you are an intern, you should call it out that post-mortem, doing the RCA is not about blaming anyone. It is about figuring out improvement in the process.
Right. And actually, like you were saying, I think it's good for the company too, right? I mean, if you don't have
Absolutely.
a culture of blameless postmortem, then people will try
Right.
to put things under the carpet, and then you will find your solutions later rather than earlier.
Absolutely.
Right.
So this, the company I used to work for, Fab, like, this is something I very fondly remember this, that our CTO, Nishit, very, very inspirational person, of course, he had this weird thing that when the systems will be down, and then he will come laughing. He would say, okay, क्या फट गया है, ठीक है, कोई बात नहीं, साइड डाउन है, कोई बात नहीं, चलो देखते हैं क्या फाड़े हो, बताओ. And that, that is very, very important, that, being able to laugh at such situations, and then, like, fine, फट गया, कोई बात नहीं, let's figure it out, let's fix it, right? And there is no blame on anyone, तुमने किया, तुमने फाड़ दिया, बहुत बढ़िया. So, I think that culture is super, super important. And another important thing is that often, we believe this, that the culture has to only be top to bottom, that the, how CTO is behaving is going to define the culture. That is not so. Culture also gets defined bottom to top as well. No matter where you are, never hesitate to call out the right thing. Say, this is how we should be as a company, what we should be as a company. Stay humble, remain open to get corrected as well. But, do not just say that, if there is something wrong happening and the big guys are doing it, so let me just live with that. Call it out that, I believe, of course, in a polite and, way where you are also open for correction. But, I believe that we should do it in this way. This is what is the right way to handle this, instead of, just, let's say, shouting at people or trying to shift the blame game, etc.
So interesting, actually. I mean, so at Coding Blocks also, an anecdote is, Varun, who has just joined our product team. So he was that time, I was co-founder, he was CTO, and we had a team which was largely very young people, interns mostly. So anything is to break, like, चलो अच्छा चलो ऑफिस चलते हैं, and आज तो रात को बैठना पड़ेगा, तो यार मतलब किसने फाड़ा, तो भाई चलो तुम बिरयानी मंगाओ, और अब तो रात को यही ऑफिस में जाएगा, आज तो भी इसको ऑफ करना है. So we always try to set up that culture that let's all sit down, we'll do a hackathon and fix all of these things. Let's order food, and we'll order good food and we'll eat well and fix all of that. Because solutions come in systems. Like, mistakes happen by humans, but the solutions has to come in the system.
Absolutely.
Exactly.
Actually, on that, a very interesting thing that, in our Fab office of New York, we had a big board in the office which read "Make mistakes." It is totally okay to make mistakes, but keep learning, because the more mistakes you make, the more you will learn. Right. And similarly, I think this quote of Facebook was also famous in the very early days. They had actually a board with that in the office: move fast and break things. Right. That build things very quickly. It's okay if some of the things break in production. We'll learn from it. We'll make sure it doesn't happen again. But let's move fast. It's okay if things break. That culture, and actually, I think that is what this culture is what led to massive success of these companies like Facebook, etc.
Right. And it is very encouraging that these days I see all the JDs for SRE DevOps team having this blameless postmortem. They are writing in big letters out there. So it's a good culture shift that across the industry it's happening. It's getting promoted. And then I think we have our final question. And, so this is, I think, again, it's a community source question, and people have asked this actually, especially people who are in early stage startups. So when the company starts growing, so smaller tech teams, you generally have people on whom a lot of dependency is there. So if that person is out sick, then you can't even fix certain things. That only that person has credential to the production server to up something, or only that person knows exactly the certain steps that are needed. So those kind of dependencies end up existing. As teams grow, explode and grow, then this can create like a massive problem. Any tips around, how to mitigate this kind of a thing as teams grow? What are the steps we should follow for this?
Right. No, so see, of course, it's pretty natural that if it is a very, very young company, there can be certain know-hows that the person knows, right? let's say when InterviewBit was a company with 4 people back in 2014-15, it's possible that there is some stuff that only I know, or there is some stuff that only Anshuman knows, or some stuff that only Tushar knows, right? But as a company grow, it is very, very important that we start putting the processes in place, right? When you are a small company which is being used by just 10, 20, 50,000 people, fine, even if it is down for some time, maybe like fine, big deal. And however, the human dependency, as we say, that we need to admit that as humans we are very, very fragile, right? And we are not really that efficient. So it's very important that that is why the habit of documenting things, habit of writing things down, that is super, super important. That whatever you are doing, whatever, like it might be credentials, it might be know-how, it might be the design, that how things are together, what are the dependencies between different systems. I think the sooner a company starts this habit of documenting, it also helps with building greater clarity, right? Let's say if I am doing something and I write it down, then immediately after writing it down, I might be able to see that how it could be even better. So that is one. And second is that when I have written it down and it is a shared knowledge base across all the team, then let's say even if I'm not available, let's say if I'm out of network, or I'm not well, whatever it might be, right? As I said, that humans are very, very fragile, right? There's always someone who can say that nothing to worry, Abhimanyu, you take rest, you are not well. We will go through the documents, and we would most likely know everything. 99% of the things we would know, and we would able to manage it, right? However, when of course we never want to be part of a team where even if I am having high fever, but only I know it, so I will have to do it. Not a good situation to be in, right? So it's very, very important to reduce the human dependency, and that doesn't mean that makes anyone redundant. They will still be very highly relevant. For now, I may call out. I have even of course the banter across the software developers. I haven't even heard that let's not document that so that there is no one can fire me because only I know this, right? But that's generally your value is not about what facts but your value is about what you can create, right? So that is a misconception to have, that if you just will be more relevant if you have know-how. Rather, you will be more valued in the company if you are able to set processes, create documentations, which create such a high value for the company that then company is going to say that this guy is so structured. He brings so much structure to the company and our processes. It makes us so much robust that we should give this guy promotion and more better hikes than anyone else, rather than the person who is just trying to just keep them everything to themselves, right? So even for your growth, I think to grow into leadership and keep being an important person in the team, it's a better strategy to kind of set up processes that we are going to document everything, we are going to put processes around everything, that even if I'm not around, there's nothing dependent on me.
Right. Very, very actually add to that, because recently talking to a lot of tech leaders myself as well for some product related stuff, and I keep hearing that SD1 to SD2 people say that understanding system design is important to grow. SD2 to SD3 everybody says that being able to explain to your juniors what you're doing, that is the most important skill. They say by the time you become SD2, tech wise you know almost everything. But now are you able to explain it to other people? If you can't, then you will not go from SD2 to SD3. That's what all these tech leaders are saying. So that's super important, that I think that's the crucial part of reducing dependency on yourself as well. Unless you can teach people, mentor other people, you won't be growing. I think great insights. Thank you, Abhimanyu.
Awesome. Thank you guys.
Hi, I'm Mohit Yadav. I teach at SCALER. I have led teams at Hotstar and Nutanix where I got a chance to build massive scalable products. The pipelines out of that I built scale to 1 terabytes of data per day. The API was able to scale for 10 million users. So that's my background. We have other guest with us who's Arnav. Arnav was basically the founder of Coding Blocks, and he heads mobile department of Zomato, right? So both of us are here today to talk about how do you debug applications in production, right? And we'll give both perspective this time. We'll talk about front end and client side, and we'll also talk about back end, right? And for that, we launched a couple of polls on Discord and our Telegram channels to identify what are the major issues and what are the major questions that are coming up, and we've sort of added them on the right side of the chart if you look at. So we'll go one by one or over each question. Right. So let's get started. The first question that we sort of want to talk about is, what are some of the key points we need to take into consideration while designing applications? Arna, do you want to take it, talk about the client side first, and then maybe I can give some backend perspective.
Sure. So that's basically keeping the broader theme in mind that, how to, debug in production, how to make things in such a way that it's possible to debug in production. In that angle, I'm just answering about design. So there are a bunch of things. I think the most important thing is obviously having monitoring and alerting in place before you go to production, before your product is up there with millions of people. So there are actually a bunch of things there, when we talk about monitoring as well. So one is that, your crash reporting framework. So that sort of Firebase and crash statics have almost become a de facto standard with mobile apps, at least. With web frontends, in fact, by the way, Firebase can be used with frontends for crash reporting as well, but there are other frameworks like Sentry and all also exist. So that's basically your, whenever some crashes happen, you have the logs for that, and you have the stack traces for that, and you should be able to sort of trace exactly why that happened. There, one caveat or one more thing is very important, is that you should have your source mapping properly set up. So basically, for web frontends, you generally minify your code. Your JavaScript code gets minified, so your variable and function names are all mangled. Similarly, when you are on iOS or on Android development doing that as well, then also you're obfuscating your code. Again, same thing happens. Your symbols, variables, function names, they're all mangled again. So you should have like a reversing those back to your actually, so that you can map to exactly which line of source code, which function actually crashed. The source maps need to exist. You should have the source maps properly in place with your crash tracking framework, so that the stack traces make sense. Otherwise, the stack trace will come and you won't be able to make sense. That's about the crash part. The other part is user behavior tracking also needs to be there, so that you can sort of recreate the exact way the user reached that particular place. So there are a bunch of things. The click streams are there, which is, you basically log what all IDs of entities in the screen, buttons and cards and all, which the user clicked one by one, and there is a log of that. And there's something called breadcrumbs. So breadcrumbs, like generally every page transition that happens, we generally drop a breadcrumb. Breadcrumb is basically just a log line that, okay, this activity opened, this fragment open, or in a web app, it would be like this root got changed / articles went to / users, something like that. Okay. So breadcrumbs are dropped. They help you recreate the user journey, how they reach that place where that happened. Right. And then for product people, for analytics people, we set up things like, ELK or Kibana based things for, just collecting the logs as well. Those things also need to be set up. That's about basically the monitoring part. Another thing that when you're designing applications, it's I feel very important is it's going to be running on your user's device, not on your device. It's a client app that will be running on a browser or mobile phone. Resources could be scarce depending on what kind of device that person is using. So properly profiling memory and being able to detect memory leaks wherever those are happening, reporting on that should also be available, so that you can keep track of the fact that, if there is some resource bloat that is happening on your apps, and that will put off a lot of people that, this app or this website slows my computer down, or when this app is open, then other apps are not able to work, things like that. So being able to monitor your memory profile is important. And finally, one very important thing, which is not really about debugging as such, but general, performance, I would say, is that, working with these streaming HTTP responses using HTTP 2.0, where before the entire response has come, you can start showing something on the screen. Or you can use compressed API response. There is gzip available, and there is an even newer one Google has made called Throttle, BROTLI. It's a compression screen. So those, using compressed APIs, those are important. Wherever you're using images on the front end, again, probably having a separate URL for thumbnail, which you can first download 1 KB, 2 KB size thumbnail, and then download the 200, 300 KB size actual image, so that there is a okay-ish looking placeholder before the actual image is downloaded. Progressive loading of images, we basically call. Those kind of things are sort of set up properly. Pagination of your APIs, again, those things are needed. So I think roughly keeping these things in mind, I'd say are important when you're designing front end. Off to you, like what do you think are sort of important steps for the backend?
Yeah, that really helps. So I'll also start with the same monitoring setup, right? So I think irrespective of whether it is infra issue or a client issue or a backend issue, one thing that really helps in debugging is the kind of monitoring metrics that you've set up. But in on the backend side, it's primarily on the percentile metrics, right? That how many percent of your users are able to get a response within X amount of time, or people typically measure average latencies, or maybe what is the mean latency. But if I have to extend it, right, I want my 99% of my users to be happy, or maybe 99.9% of my users to be happy. So measuring these matrices, like in terms of response time, and how many 4xx are coming, how many 5xx are coming. If the 4xx are alarmingly high, I just go and check whether I'm getting lot of unauthorized or 403 kind of errors. That means that will give me a hint of attack, right? A person is basically trying to game my system because I'm getting a lot of forbidden error. If the just imagine a scenario where 50% of the users are, or 50% of the requests are translating to 4xx errors. That is a hint to you that it is an alarmingly high number. Maybe somebody is trying to game your system. Bump up your infra security team can be alerted based on that. If the number of 5xx are really high, so typically always look at the kind of HTTP response that you are getting and log it. If that response is alarmingly high, then raise an alert. So this brings me to the second point. After you have captured all the metrics in monitoring part, you raise an alert. Alert can be automated, right? In automated alerts, you can typically, one type of alert can be that, hey, my CPU utilization for one server is really getting high. So I might want to add more instances, because the kind of request that this particular server can handle, it's no more able to handle those many requests. So I might want to add new instances. So this is an automated trigger and automated resolution as well. Similarly, if the CPU utilization, for example, is very low, that means there is very little load on my system, and I can typically decrease the number of servers. So these are automated kind of responses. There are automated checks that I can have. Then there are unautomated checks, or which would need manual intervention as well. Those kind of checks would be, for example, the security vulnerability that I pointed out, right? So if you're getting a lot of unauthorized access, that means you need to maybe tell a person that, hey, this is something unusual. Please go and check, have a look at it. Why is this kind of error? It might be due to maybe the API function. I've changed the API token, but my clients have not, I've not sent that token to the client, and they're still sending the wrong token or wrong salt key, due to which I'm getting the error. So it might be due to a bug as well. So net, this is where a manual intervention would be needed, right? So classify your errors based on whether you can, resolve them automatically. If not, have an alerting mechanism. Alerting mechanism should be such that the team who's responsible for that particular error is alerted, right? Not everybody in the team would be able to debug a security issue, for example. Or if it's a particular microservice, then you might want to alert the person who's written that particular microservice, or who's the owner of that particular product, right? So those are the typical things on the monitoring and the alerting aspect. Another important aspect when it comes to debugging is distributed tracing, right? So I'll explain you what I mean by distributed tracing, right? Imagine that you have designed a homepage of a website like Netflix or Hotstar, right? There, if you notice, you see a lot of personalized content, and then there are promotional content as well. For example, if GOT is releasing, I'll probably push GOT recommendation, even though whether or not you watch English TV series or not. But since it's a new release, I have to place that content in your homepage. So typically on the backend side, how it's done, it's from the UI, it will call just a single API, right? It can be a backend from front end. We'll go into that aspect as well in the later part of the discussion. But assume that the entire homepage is getting fetched from a single API. In that case, to get the response of that particular homepage, you would need to call multiple microservices or multiple services. One would be giving the recommended content. One will be giving you the editorial content. And let's suppose one user gets an error. How would you go and debug this? The problem in debugging, what I'm trying to highlight over here is that particular request is flowing through multiple systems, right? And let's say the exception occurred in the recommendation part. You would not be able to trace what was the original request, because the first system gets a request, goes to two systems, and this system got an error. So error is here. You don't know what was the request, what does the request look like in the other systems, right? The first system or the second systems. You need a system which can uniquely identify every request that is getting added to your particular system. And this can be easily achieved by adding a unique ID or a UUID with every request. So what typically people do, I'll just explain briefly what distributed tracing is and how it works. So what people typically do is, as soon as the controller in the application gets a request, the API controller, the REST controller that you've exposed gets a request, what happens is it associates itself with a unique ID, right? It can be a UUID, which is guaranteed almost every time it will be unique. Then that unique ID is within the scope of the application also, it is passed to different circles. Like you can just place that particular ID in the heap, and anyone who wants to refer to it can typically refer to it from the single heap location that it has added. To pass it to external application via HTTP call, there is a REST guideline. You can place that particular value inside the headers, so that my dependent application also knows what is the request that I'm trying to process. And that is how every system, it can be 50, you can be calling 50 different microservices or services, right? Even then, I have one ID. As soon as I go to my logging framework and I encounter an exception, I can just check what is the ID associated with it, and I can totally draw the entire set of how the requests flow through my entire system. And that is something that typically, very speeds up your debugging process to a great extent. So these were the top 3 things that were coming to my mind initially. Let's go and see how problem changes when it comes to scale. Scale brings in a lot of different challenges in itself, right? And scale have different meaning for backend and for client as well, right? Scale for backend means that earlier my system was catering to, let's say, 10,000 users, but it shoots up to, let's say, 100K users or 1 million users, or maybe 10 million users. And if you're at a Facebook scale, maybe a billion users as well, right? So scale basically varies for backend and frontend. So obviously the way of handling the scale also differs, right? I'll start by talking about a little bit on the backend, how it is handled at backend, and then I'll let Arnav talk about how we can manage it on the front end as well. As I said, on the backend, when the requests are increasing, right? So if we all know, one single system cannot handle all the requests that are coming to it, right? So we try to scale it horizontally. How do we do that? We place all the instances behind a load balancer, and if the need comes that there isn't a lot more scale, a lot more other users are also coming, then we add more instances behind the load balancer, and that's how we scale the application servers, right? There is a scaling required of the database layer as well, which is stateful scaling. The one that I just told you was primarily on the load balancer side was primarily a stateless scaling. The benefit of keeping my system stateless is that, so by the way, if you guys don't know what stateless and stateful means, the difference between the two is that one-liner difference is that the data, if it is stored within the instance, it is stateful. If the data is not stored in that particular instance and that is only used for compute, or maybe calling multiple services, club the response, then it is a stateless system, right? So when it comes to scalability, it does make sense to keep your system stateless. Why? The routing becomes very easy, right? Whenever there is an increase in the load, you can just go to the load balancer and add more instances, and your system will run. The reason it will be able to run is that there is no data which is stored, right? We are only using it for compute. So it will be able to scale much faster and have a automated trigger built in, right? When I said in the beginning that have some monitorings and alerting set up, and if the disk is getting full or CPU is getting clogged, you can add or remove more instances. When it comes to automated scaling, and when you are talking about a scale where you have millions of users, it becomes absolutely necessary to rely on automated triggers, because you will never know. Humans can make errors, right? Maybe you have deployed a person whose basic job is to look at the metrics, and if the metrics is spiking, he adds 5 instances to it. Now, the kind of errors that can come up here is that the person can come back to me and say that, hey, I forgot about it, right? मैं तो भूल गया, मैंने चिल ले लिया, या फिर मैं कॉफी पीने गया था, I forgot about it. So to avoid such human errors or negligence errors, we should have automated triggers, and the kind of instructions or the kind of rapidness that comes with having automated triggers, manual process cannot match that. And using that, we can basically set up that, hey, if my disk is 80% full, attach one more volume to this particular EC2 instance. If my CPU utilization is going beyond 70%, add one more instance, right? So these are basically strip functions, and maybe you can have a max count that do not increase the count beyond 100 instances or 150 instances. So this was one point. I'll come to more points, but I'll let Arnav also talk about the scalability challenges that typically come up in the client applications.
Right. So no, this is a very, I think, challenging space. There's also a lot of misconceptions. If people have not worked at scale, then when we talk about scale for front end, people have a lot of misconceptions around this. Now on front end, the thing is that scale works in a very different way. By the way, like there is a famous story that WhatsApp had, I think, some 500 million users when it was getting acquired, and they had a team of only 19 people, entire company. I think, as far as I remember, the news story that broke, 19 people, not just front end team. I'm saying a whole of WhatsApp was 19 people, 19, 20 people when I get acquired. So how were they able to do that? And does that mean that if you have 500 million people, you can always run with a 20 people team? Some companies might have 200 people team also at that scale. Now, what happens with front end is that the scale is more about the variety of scenarios in which your client is running. It obviously is not so directly dependent upon how many people are running, because at an individual level, the front end is always running on one device at a time. So if you have 10,000 users, if you have 10 million users, your front ends, each instance is only running on one device. But what starts becoming challenging is that, say there is some particular, random laptop on which some particular very not so frequently used browser, inside which a certain, say CSS thing does not work. Or similarly, there is one particular Android device made by some particular manufacturer on which, background services don't work. Now, if you have 10,000 users, maybe 2 people are affected by that, and it's a rounding error. You check it. You say, I think 2 people will not be able to use it. What can I do? But then when you're 10 million kind of audience, and there are 2 things can happen. One is obviously just extrapolating from that, from 2 people, it becomes, 2,000 people and all. But more than that, what happens is that because the audience has increased, now you get a lot of people. So from my experience, I'd say Zomato was that as we expanded from top 20, 30 cities of India to 500 cities, we found people using much lower end devices on much worse internet connections, right? So then we have to cater for many more types of environments in which the app is end up going to run. And that becomes the challenge of scale at that point, that, what was a corner case, 1/10 of that traffic, now it's not a corner case anymore. It's a pretty significant problem for us. So that's there. The other part about scale is that, your backend can only suffice in terms of performance up to a certain level. A lot of the points that, Mohit, you were saying till now, very helpful. And as your backend partners for when you're making the app, or whoever is your API partner, community partner in your team, they are going to be doing a lot of effort. They're going to be making performant and all. But beyond a certain level, there will be limits that you reach at the speed of the query and the size of the data that you can fetch. So then you need to add some client side augmentation for that. So, paginated API requests, API layer optimization, where the client can sort of, fetch only the part that is shown in the screen first and delay loading the later part, so that the server does not have to send you maybe a list of 50 items. They can send you a list of 10 and the list of 40 can be loaded later, something like that. These things come. Then there are, I think, a little bit more just touching upon is like BFFs start coming. So BFF, for example, at my most recent workplace, which is Target. So there, a BFF, the front end team's responsibility is actually maintaining a BFF. A BFF stands for backend for front end. Now the backend itself has a bunch of microservices. Listings detail of products is coming from some place. The order detail is coming from some place. The user account detail is coming from some place. And then the app team basically creates a middleware server which collects them together and makes one single response that becomes the homepage response. So that the app can make a single response, homepage API. What happens is, for example, in client, a lot of slowness also happens out of the latency rather than actually server's transaction speed. Maybe for showing the same page, for showing the same data, if you're fetching it from 5 different places, the latency of each API hit also adds up. There's going to be 150 milliseconds of latency that will get added up if not, edge is not in the same country. If the edge is in the same country, then 20-30 milliseconds will get added up for every API transaction that's happening, right? If 5 API calls have to happen and then only you can show the data on your screen, then that 5 into latency won't be able to sort of prevent that. Now, that's the place where something like a BFF can help, that it will do the aggregation at a server level, at the edge level itself. And then from edge to app, there is one API call. So latency is only one time. Then there is also the scale of features, which I say. So scale is also about features. Now, too many features are there, too many pages are there in your app. The team that you're working on becomes big. There you have to work on scale, is that you split your team in terms of features or, different user flows. And then you do something called client sharding. Very hard to do, actually. Basically, you divide your front-end team and then they take care of different front-end parts. And in terms of front-end frameworks, there's a concept of micro front-ends, that you develop features of front-end very independently and then they can be plugged together. And similarly for iOS apps, you create separate frameworks. Android apps, you create separate graduate modules, which together become the app. I have some friends, for example, who are at Gojek. It's a very popular example of something called a super app. So they have bunch of completely end-to-end user flows, etc. Food delivery to shopping. Like in India, there are a lot of different apps we use for different things. In Indonesia, many people use Gojek as a single app for 10 different use cases, for which we all have 10 different apps. So they develop it like 10 different apps and then they compile it together into one package and they distribute it as a single app. So that's something that comes up. And then finally, in terms of design is also very important, is that having a cohesive design across the entire app. What happens over time, bigger teams, they generally start having separate design team or a design platform team. And they create your dictionary of components that you use to build the front end. So, how the button would look like, how a card will look like, how a checkbox would look like, how your input forms would look like, how your page animations would look like. They need to be same across the entire app. So why should every team working on every feature put effort into that? Instead, you create a very atomic design toolkit that, okay, smaller components, one common team will build, then every feature team will pick those components and use it in different places. So, I think these are some of the steps that you need to keep in mind while, your front end scales.
Right.
So, I think next question that we have, I think.
I'll add a couple of points on.
Sure. Go ahead.
Yeah. So, the point you mentioned about client sharding, right? I wanted to give one anecdote that I saw in Hotstar, right? So we came to a point that our backend teams was like, "Humne haath khade kar li," and I can't do anything now. And it was up to the client team to assess the backend teams to have the scalability. The use case was that if you saw play and watch, right? You can just watch a cricket match and guess the outcome of the ball. It was basically a game within a particular app.
Right.
There we were basically calculating the score of every user on the client, and after the end of every over, initial design was that once the over is finished, then the client team will basically fetch the data from the backend, and that is how we are going to be using it. But what that led to is after end of every over, right? So that event is same for every user who's there, who's basically watching the match, and that led to a huge spike in the whenever the over ends. Our backend server was bombarded with multiple requests, and throughout the over, there were no requests. So that is where we assigned a ID to every client, and we said that, hey, modulo 10 is what is the delta, you're going to add. That is basically a delta delay that you are going to call after 1 second or 2 seconds or 3 seconds, and that is, they'll continue doing that. So what we did was we reduced the load on the backend server by 1/10, right? So like that really clicked me when you said client sharding. I don't know if I've
actually, we did something similar at coding blocks as well, at a much lower set of scale itself. But the problem was we did not have sort of auto scaling kind of a thing where servers can automatically increase in number when load comes. And we used to conduct some of these scholarship tests. And generally, like the backend is running, code is getting judged, even like 2-3 requests per second are sort of coming. And these are heavy requests, like entire code is getting submitted, test case has to run, right? So already a lot of servers are running. But then when the scholarship test happens, then, first of all, the people who want to start the test, that usually suddenly 50,000-60,000 users together want to start the test. And that's a very different scale from at any other time, there are only 200-300 users online. And here 50,000 users will start, right? So there we used to do something similar, that we used to divide people into buckets. And if the test is supposed to start at 5 p.m., then for 1/10 of the people, it will start at 5. For next people, it will start at 30 seconds later. For the next 1/10, 1 minute later, like that, we used to distribute that. So yeah, these kind of hacks are sometimes needed, because sometimes it's like either there is a physical limitation itself on the backend that you just can't scale beyond that, and sometimes it's like a prudent call on your end. Like, why set up 20x more servers when you just need it for that one spike? You can probably distribute that spike a little bit more. So like, people were saying flatten the curve for that coronavirus thing. It's kind of similarly like that. If your capacity can't handle such a big spike, then flatten that spike during that time.
That's right. Cool. So I'll add more backend points that you should consider when you are scaling the application. So I already spoke about keep your server stateless, set up infrastructure that supports auto scaling. Next point is very critical for auto scaling perspective, right? That is that you have added a stateless server, but when you add a new server, what are the typical things that are involved? One is the OS should boot up. After the OS is boot up, the app server itself will take some boot up time. So if you start a Java process and run something like Java -jar, then you run the process, it also takes some time. It will start up a Tomcat server if you're running a Spring Boot application. It will start a Jetty server, or maybe a Undertow or Netty, or basically some server which is able to communicate via REST APIs. So that also will take time. So keeping or choosing a stack, especially when you are dealing with millions of users, choose a stack which has least amount of boot up time. And instead of booting up instances, try to Dockerize or containerize your application so that launching a container is much faster than launching an EC2 instance on AWS, right? Or maybe launching a new server in itself. So keep that in mind, that your boot up time should be as minimal as possible. Then another thing that we need to scale when it comes to scalability in the backend system, especially when you are trying to scale your databases, is so databases does two things, right? It support read queries and it support write queries, right? Delete, update also comes under the write part. So when you are not able to, let's suppose you are designing a system which is write intensive. In those cases, try to shard the data so that you have multiple servers which are basically meeting your storage requirements. But the other kind of problem that comes up is the read as well. Let's say you have stored the data in one place, but the number of reads that you're getting are enormous, right? For example, Aadhaar data. Right? Once you've entered the data, many times it will be read multiple times, but updates are going to be very less, right? Or maybe creating a new Aadhaar will also be a very less frequent job as compared to reading it. Similar is inventory showing on an e-commerce website. Your inventory is fixed, but the number of users who are reading that particular inventory are huge. So what you do is you create multiple copies of this particular data and keep it at multiple places. There are 10 servers who are keeping the exact copy of the data, and whenever the request comes to your application server, all the 10 servers are basically capable of returning a valid response. So replicate for read scalability and shard for write scalability or write throughput. And whenever possible, try to add a queue whenever you are having a batch operation, right? For example, if you have to, let's say, calculate monthly payroll of employees, that is a batch process, right? You don't have to calculate the payroll of every employee every time, right? It's after maybe at the end of the month, it is a batch process, you'll run it and then you're done. In those cases, you don't have to, let's say if you have 200 employees and your servers can process only 10 requests per second, you don't need 20 servers, right? You can live with maybe one server and process it. Start the process maybe on 30th of every month, and by the end of the day, all the 200 employees will be processed. So try to utilize workflow systems and queues for having such kind of scaling challenges. So yeah, those were a few scalability tips that I wanted to add. I think next question is also very interesting, which will give you an idea about what kind of tools that are quite essential when it comes to debugging a particular application.
Right.
I'll let you answer this first, and then I'll come back.
So tools, I think one thing I feel actually a little bit off with front end is that there aren't a lot of actually very open source tools in as such for monitoring and all. Sadly, the current state of how open source software is like for example, mobile and all, it's mostly common is that people are using Firebase. Now, Firebase has a lot of things inside that. So when I say Firebase, I don't mean entirety of it. So Firebase has got database, Firebase has got push notifications, bunch of things. The Crashlytics, which actually used to be a separate service, got acquired by Twitter. Then like that whole bundle called Fabric was acquired by Google. So it has a long history. So, but it's a fantastic tool for crash monitoring that's there. And then there are a few other tools as well, which like Crashlytics is very, very Android focused, but these days iOS is also using it. In most big companies, Android and iOS native apps would most likely be using Crashlytics. Sentry and Bugsnag I have seen also getting used a lot. Right. Sentry essentially is open source though, and it's available as a Docker container. You can run it on your own server as well. Sentry does get used a lot, which I have seen. And then there is for application monitoring, there are a few tools that are there. Datadog and New Relic kind of tools get used. I have seen. One more important thing is that along with these tools that we need for debugging and monitoring and etc., we also need a little bit of security side tools as well with our apps. So code obfuscation and encryption and these things. So using things like AppGuard and ProGuard, which basically obfuscate your code, or when you're using something like web front ends, mostly your bundlers, which is like Rollup or Webpack, those will automatically also do the same thing for you. So those are not like some bulletproof security measures. They work on security by obscurity, so that your code does not really remain much readable anymore. Because most front end setups are such that you can't really make super hidden code binary level, which you compile a C++ program, it becomes a hex file. You can't really get back to the original C++ code at all. With front end, what happens is you can sort of decompile bytecode of a Java app back to some kind of Java source code, and with JavaScript directly runs on the browser. There is no source code and production code. So their obfuscation kind of methods are the only way to add some security there. I think that's sort of the things that are there for front end. I think what do you use for monitoring, telemetry, uptime, and all, alerting, and all? What tools do you use for backend? Any ideas for that?
Sure. So I'll structure my content like what tools are required for monitoring and maybe distributed tracing and for alerting, right? And what are their uses. So for monitoring and alerting, the major tools that I typically use is, so I'll talk about the open source first, and then we can talk about the paid ones as well. So open source, in the open source code, LStack is something that is very famous, right? LStack is Elasticsearch, Logstash, Kibana. You can push matrices to Elasticsearch and have a detailed monitoring of all the components. If you just want to push logs and search based on logs, that is also possible using Logstash. There is FileBeat, which will periodically look at the logs that are getting added to a particular file, and it will push it to Elasticsearch. And Kibana is basically used for dashboarding and if you want to visualize the data and maybe set up alerts as well. These alerts are not that great. What I typically use, specifically use for alerting is uptime, which will give you a very good status about which services are up and which services are down. It works on a health check kind of a URLs. For example, if a particular API is down, or if a particular service itself is down, its health check will fail and we'll get an alert for that. Other variants that you can typically use for visualizing the metrics. Let's say you want to measure the latency of a particular function. In that case, you can use you can use Grafana and Graphite for basically visualizing, and you can use StatsD for sending out the matrices. Let's just annotate or write a aspect which will measure the latency of a particular method and push it to StatsD. StatsD will you can integrate StatsD with Grafana for visualization, right? So every developer who's basically developing it, right, and wants to work in a open source kind of a setup needs to know this tool, right? These are the de facto student regardless of what kind of microservices you are. If you're working in a company which is which has a lot of fortune and you are willing to spend it on tools, then good paid variants would have Splunk. There is New Relic. There is App Dynamics. These will in fact give you the memory profile of a particular server as well. So let's suppose if your application is running into 10 servers, it will list down all the 10 servers, what are the memory profiles, what are the objects that are getting passed, what is the latency of each server. It will raise alerts, alerting and monitoring both. It will take care. It will also integrate with other paid tools, which can basically give you a call if a particular service is down, right? So most of you would have heard about on-call duties in Amazon, right? So the funda of on-call duty is that one person will be available 24/7 for a certain period of time. So funda over there is they'll get a pager duty, they'll get a call, they'll get a Slack, they'll get email, they'll get bombarded with all the on all the channels, and if there is any error that is not noticed. So that was basically around error monitoring and alerting. Another important aspect that I touched upon initially was around distributed tracing, right? And I think there is some question around that as well. So what should we use for distributed tracing, Jagger or Zipkin? Or so what I have used is I've used OpenTelemetry and Zipkin both. I've not used Jagger, so both of them are good. Zipkin is primarily Java-based. OpenTelemetry is a polyglot system. That means that you can use it with Golang, Python, any language, right? It works on the HTTP standards, not on the Java standard. So you can use OpenTelemetry for that. And yeah, so those are primarily the tools I use for my monitoring purposes. Any thing else that you want to add?
When talking about tools, another thing I feel is that your development time tools are also very important to have. Like one is that in production, how do you debug and how do you find out things and all. One thing I'd definitely like to point out is that for front end, actually when things really go wrong, at that point, there is very little to do, because for web frontends, it's already cached with the user. You can't, like that, redeploy frontends everywhere and people will get the new website. That does not happen. With apps, it's even harder. Actually, your deployment cycles are generally 2-3 day long. So even if you can fix it within 5 minutes, you put the app on the App Store or Play Store, they will take 2-3 days to review it. And then the user ramp up is also going to be very slow. So something like OnCall, like you were saying, and that actually sort of triggered me to say this, is that in front-end teams, you will never have somebody on call, because there's just no point. Like, what will the on-call person even do? They can't fix things. So being able to, sort of monitor, replicate, and fix a lot of the issues at development and debugging stage, then essentially becomes a lot more important. And kill switches become also very important in terms of front-end. So basically, the ability to sort of like most bigger projects that I have worked with, they generally do is like, say, when the app boots, whether it's a web app or whether it's a mobile app, like boot up being in terms of web app, generally when a SPI hydrates, like your web request is made, the web bundle is downloaded, and websites like Facebook, Twitter, and all these are actually like essentially like apps running within the browser these days. When they boot up, they would make a configuration call generally to the server, which would tell them that, okay, say for example, a certain service is not working. The server would, send an appropriate response, as a result of which that particular tab will get disabled on the front end. Those kind of things also need to be in place. Being able to have fallback mechanisms and being able to disable certain services as well based on some configuration requests in the beginning. That's important to have in place, because if something is actually sort of crashing, then it's very hard to kind of resolve that and then get a fix in place and deploy it and get it adopted very soon. What is possible is to prevent people to get to that place where that crash is happening till this happens, and you need to have systems in place that can probably do that.
Like we can't really do anything if something goes wrong in the client side. Kill switch is the only thing that we can do. Cool. So we'll start taking questions. We can configure rate limiting on the API gateway. I guess he's basically referring to the first example that we said, right? Where the load on the system is getting really high, and we can typically add rate limiting. I think I'm aligned with that. We can do that. Just that if you add rate limiting, and because of rate limiting, X number of requests are getting failed, keep an eye on that as well. So if you're rate limiting, maybe you'll send a 5xx error, and keep an eye on the 5xx error also. It should not be that more than 5% or 2% of your errors are of your requests are actually getting rejected because of the API rate limiting aspect.
And I think to add to that, the rate limiting can happen at multiple layers.
Right.
Like from my experience with Zomato was that there was a sort of rate limiting logic on the clients itself. Then there was rate limiting logic on the edge, and then there was rate limiting logic on the application layer. So on the client, actually, what kind of rate limiting happens is that we are tracking a lot of user metrics, like everything, like a person is searching, opening a restaurant, all those events are going. These days, every app collects a lot of data about you. It helps them, give you more curated responses and all, right? Now, this data that's collecting, it's all going into a data engine analytics server. It's going, right? Now, there, if for example, the last chunk of analytics, if I try to upload and it failed, for example, then it will retry 1 second later. If that also fails, then the second retry happens 5 seconds later. If that fails, then another retry happens 10 seconds later. Like that, it's a throttled retry happens. Now, that is there because the API where the sort of logs are getting collected, somehow if that's clogged or something, then we don't want all these 30-40 million active Zomato users to sort of DDoS our own server if the logs are getting clogged. So the client should throttle back. They should, if they're not able to send the request, they should slow themselves down. those kind of. So that's basically like a set of rate limiting that's happening on the client side itself. So there's multiple layers where you can add that rate limiting logic.
Where do you think routing should take place, in the front end or back end? So any kind of routing that we do on the client side, then we'll talk about the back end.
So I think here he's talking about probably SPAs versus MPAs kind of a thing, where single page applications and multi-page applications are there, where sometimes the routing is actually happening on the like appear to happening on the URL bar, but the page has not actually been refreshed. Just an AJAX call happening and data is getting updated. In either way, like even if you're doing what is essentially called front-end routing, in that case also, like at an API level, you need separate routes from where the data is getting fetched. So your backend will definitely have routing. At front-end, you might have like front-end level routing via an SPA, or you might have a more dumb front-end which does not handle routing.
I think one more aspect to this question is that I think this question popped up when I was giving the example of designing homepage for Netflix, where I was supposed to call multiple APIs. So from that perspective, I think this question lies. So backend way, obviously you can do such kind of routings, and we can talk about the trade-offs. So this is kind of that scenario, BFF, right? Backend for front-end kind of a scenario where you're calling a single API, and that server is basically routing the request to multiple servers. The benefit that you get out of it is that I can dynamically change the places where I'm fetching the homepage for, right? From a client perspective, you just have to call one API, and that will fetch the entire homepage content for you. But if you do it, if you give this particular logic to the client, that hey, to render the front end, call these 10 APIs, then render the homepage. The downside of this is that this particular logic has to be implemented by every client, right? So in Hotstar, we had 10 different clients, right? We had iOS, Android, Fire TV was there, there's PlayStation, there's mobile web application, then there is the website. So there were multiple clients that were there. So if we give this particular responsibility to the client, every client needs to do it in a uniform manner. And typically clients team are different, right? You'll have separate set of team for iOS developers, separate developers will be working on and making the Android app, and there will be single developer for less prominent devices like Fire TV or Roku TV. So bringing them all the different teams on a single page also becomes a operationally challenging task. So if that's the case, it makes sense for a backend. Happy to hear your thoughts also. I don't know if you.
Yeah, I mean, apart from having to implement in every client, it's also that client logic is harder to update because some of the clients, like if it is a like the app properly, like an installed app, whether it's a mobile or PlayStation, Fire TV, these kind of cases, then the user has to update that app to get the new logic as well, which is a challenge in terms of user adaptation. You have to support pretty old versions. So that is also a downside. Like when you want to update the logic, you can't immediately get 100% of the users to the new logic. That's why a BFF is much better in that perspective.
Makes sense. All right. Next question is, hey, what about setting up staging and production environment for an Android app?
Yeah, I mean, this is a very common practice, of course. Like you should have a sort of you have the production, and then just beneath the production, usually something that people call the UAT, user acceptance testing. We call UAT environments are sort of 1:1 equivalent to production, but they are not used in production. They are used in staging. You can call it staging or UAT. Now with UAT kind of environments, essentially, what also is often done is that in many places, like there is going to be a debug build of the app and a prod build of the app. Now the production build would generally point to the production server, and the debug build would be pointing to your UAT servers. So you're sort of mapped out in that sense. And then you might have even further, what we used to have is team level stagings as well. at Zomato we had that, is that every team also had their separate staging servers. So if they are working on a new feature, then in the app which points to the staging version, there used to be like a hidden screen basically which you can't reach on the production app, but in the debug app you can basically reach on that screen and you can change the staging server. You have 10-15 staging servers. You can use a different staging server on which maybe a new feature has been enabled, but it's not enabled to the production yet. So you can point to that server and test those features out. So those things should be there. Like you should have a proper end-to-end environment setup where a debug version of the app pointing to a debug version of the BFF, pointing to the entire debug suite of your UAT or staging suite of your servers. You should have as your sort of organization scales, you would end up having a full end-to-end setup, exact replica of your production and staging as well, which you can very safely test it out.
I think it's for you, Arnav, again. Android app performance pro tips, please.
So I think covered some of those there. I think it really comes down to using the profiler very well in your Android Studio is very useful. Keep track of memory issues and CPU spikes and all. So use the Android profiler. Not a lot of people use it properly. So just connect that to your phone and run through your debug build once through all the screens and see where there are CPU spikes. Then you can sort of generally double click that, it expands and it shows which threads were doing too much work at what point of time, and it shows which methods in your app are running as a result of that. It's a fantastic profiler. If you're using Java on the backend, the IntelliJ IDE and then Eclipse, those have also very good profilers. And similarly, if you're using Android, then these profilers exist. And iOS also similarly export as profilers. So these tools like profilers exist, and you should definitely use them to their best capacities. Apart from that, other than that, pro tips would be general good development practices. Obviously, having a understanding of the low level design patterns, right? Like you're doing something like a dependency injection, you're using a singleton, and some memory leak can happen because of static scope is getting removed there. So those things, obviously, low level design, having robust idea of low level design is very important. People who are good with low level design, they generally produce systems where performance standards are much high.
Right. I think profiling is important for any development you do, right? Be it backend development also, to measure the performance, how much your one machine can handle, right? For that, profiling is important for backend as well. And that will give you a very good estimate about how many actual amount of data can be there in a particular application in a single server. Right? Cool. So we'll move to the next question, which is what tools would you suggest for a full stack developer? The follow up is that he means technology that we suggest. So I think I'll tell my favorite, and then maybe you can jump in, Anna. So I think here, if you don't know any language, right? So primarily, I think you can learn JavaScript, because you can typically write front end in JavaScript. Plus, learning Node would be easier for you. So mean stack is getting quite famous these days, right? So have a knowledge about MongoDB, that will give you a knowledge about the database. Then Angular will basically, again, a flavor of JavaScript, so that will also give you you'll be able to design web applications using that, and then Node obviously for backend development. That will get you started. Now, this is not for a good scalable design, but you can develop an MVP, in my opinion.
Right. No, I mean, I concur. I think I also generally suggest, like, for people starting off, I sort of blindly suggest Node.js, because same language, using that you can build, and to a reasonably good scale you can build as well. I mean,
yes.
there is a certain point you reach, maybe sort of switching to more performant language like Go and Rust and all, and can come into the question. But to a very reasonably high scale, you can work with Node.js. It's a good language, and there's the same thing. Like, the advantage of using the same language on backend and frontend is very, very good.
All right. AWS skill resources. I think one of the best way to learn about AWS is apply for a AWS free account and start playing with it. Right. That's how I learned it. And whenever you're stuck, right, AWS has a very good feature. There's a question mark after every step you are taking. So, for example, when you create an EC2 instance, right, it's quite intuitive on the UI. You click on EC2 instance, it will launch an EC2 instance. Then it asks a bunch of jargon terms that initially I didn't understand. For example, it will ask for you, ask your VPC information. Now, I don't know what a VPC is. So, there's a question mark around that. Once you click the question mark, you'll be landed to the official documentation which explains what a VPC is. So that is the best way to learn, right? It will give you a practical exposure first of all, and it will always be an updated one. If you follow any tutorial or something, chances are that it might not be the updated one, right? And you'll only on a tutorial, right? One of the things that I typically face is that they are not quite up to the date with whatever is the latest offering, and you are gated by whatever he's teaching, right? You learn only what he's teaching. Whereas if you learn it, on a self pace, you'll try to dig deeper and understand it, in all the depths that you like. So staggered spike handling, but say you don't know the number of users beforehand, and the number of users are increasing faster than the time bigger for to be added. Balancer, how do you scale? The answer to that is you cannot scale that. Right? This is one problem that I have faced a lot. Trust me. And the only thing that how we handle that is that AWS provides you one metric to scale on. Right? That will basically give you those metrics would be static metrics like 70% says other CPU utilization. So add one more instance or add 5 instances. But boot up time would go for a toss. And this is exactly what happened, what actually happens whenever a cricket match also starts, right? IPL starts at 8 o'clock till 7:50 or 7:55. There are close to 1 lakh or maybe max 2 lakhs user on the platform. As soon as the match starts at 8 p.m., this quickly jumps to 10 lakh or maybe 15 lakhs or maybe 20 lakhs users. So there's a 10x jump within 5 minutes, right? So the time to scale up those instances in this amount of time is very less. So if we just rely on the infra identifying this and then doing it, it becomes problematic. So the first thing that we did, the first solution that we had was to predict the users. We thought that predicting is basically the best we can do, and we over provisioned a lot, right? The second version was basically to take a derivative of the number of users, and that will give you a slope. If the slope is very steep, that means instead of adding 1 instance, I'll add 10 instances. So the slope became the deciding factor of how many instances I'm actually adding after a certain time. So if I add 10 more instances together, instead of adding 1 instances one by one, that becomes problematic, right? One instance, again, my CPU load is high. It will take some time, its own sweet time to add more instances. The third thing that we typically did was we moved away from EC2 instances to Dockerized containers. The reason is that now I have free CPU, the OS boot up time is basically lower, and we switched from Java to Golang because Golang boot up time is way faster than a Spring Boot application. Spring Boot application was taking around 40 seconds to boot up, and we didn't have that kind of time. We cannot afford that kind of time. So have a different set of instances and tech stack if you have to handle for spikes. And lastly, the solution that is running right now is ML kind of a model which predicts how many users are going to be actually there on the platform. And if its prediction is right, we will be able to handle this spike. If not, we'll rely on the slope. I think this is what issues are the hardest to debug. Any specific category from experience at Hotstar? I think the most difficult issues are the issues that do not give any exceptions, right? Typically, if you have to deploy something and let's say it is you've released a feature and you're not getting any exceptions, you're not getting any everything is working green in your monitoring dashboard, right? And if that gets propagated to a client, maybe I misplaced some spelling mistake, because of which that particular API is not even getting called. There are two versions. If my client teams are calling the older version, there is a new version. I am thinking that my dashboard is clean and everything is working fine, right? So those kind of issues where I don't get the exception stack trace, or I don't really know which method is basically causing that particular issue. Those are the hardest for me to quantify, or to give you more context on this. Let's suppose I'm debugging a slow API. Debugging a slow API is, to me, the hardest problem, right? It can be, the issue can be anywhere, right? It can be either due to client network calls. It can be a part, like 80% of the users, for 80% of the users, it is running fine. And for, let's say, 20% of users, it is not in the accepted range. Then it might be a server issue which is running that particular application. Then I'll go back to server, look at the logs in the server, and then try to debug it. So I think that is, to me, the hardest kind of issue to debug at the backend side. I let Arnav speak his thought around the client sides. What do you think is the hardest kind of problem?
The thing you said about exceptions not coming in, that is obviously the hardest. And one of the things I used to like as a team lead, I used to be sort of a Hitler about, is that people often, like for example, specifically say Kotlin code, is that for null safety you can use two approaches. Like, either you crash when you face null safety problems, or you wrap it around in a null safe wrapper or something like that. Now, in code reviews and in team discussion, everybody has to say them that, dude, exceptions are great. Like don't try to achieve for a lower crash free rate. Like a lot of time when you're coding, you're thinking, oh, like our app's crash free rate should be 99.9999%. And for that, wherever possible, I will try to sort of eliminate exceptions from my app. And I used to tell everybody, like, never keep your objective to eliminate exceptions, because then you will start getting bug report from a user where they will say, I open a screen, it is white, I can't see anything. And then you won't even know where to start figuring that question out, because you did not get a crash report. Crash reports are the best thing to start with, because you get a stack trace. You know exactly what problem happened. So hardest to debug always is where there is some undefined behavior happening, which when you mentally dry run your code, you see there is no way to reach such a condition. But there is no exception or no crash to actually track that. So now you're sort of hunting in the dark, that how the fuck did this user reach this particular scenario? I don't know. But there is no stack trace on my Sentry or on my Crashlytics to even go by. So I think when you're coding, wherever I would say, one thing I used to say, part of defensive coding, I used to tell them, is that wherever sort of you're writing a lot of cases that, if somebody submitted an address, if the length is too long, or there's a special character, or the pin that has been dropped does not, the geofence does not match with that address. So many use cases, say for example, right? Now you're writing a if else in a switch condition, maybe a bunch of logic you're writing. A couple of places where there's some undefined behavior is possible. Like, and I used to tell them that wherever in doubt, what to take when I have reached this particular branch in my if else condition. Wherever in doubt, throw an exception. That's the best code. Like, if you throw some exception in your code, I would definitely review that, merge that code, no problem. Because, throwing exception is the best thing to do, because then it's just so easy to identify the problems and solve them.
We should not fail silent. Whenever there is an exception, right, just print the stack trace or push it to some queue so that people who are debugging it can look it into it. What I typically see in I've seen this particular mistake made by a lot of people, that they do try inside a try block they try something, and then in catch exception, and instead of catching the specific exception, also this called the superclass catch exception EX, and catch blocks is completely empty. So now I don't know what is happening. So nothing is done. So in the catch block is completely empty. So we will not be able to figure out where exactly this error is coming.
You neither get the exception, and the user is in some empty state where nothing is happening.
Correct. Yes.
Right.
This is for you, Arnav. Some love from your fan.
Okay. So you want to become a mobile application developer, you're doing native Android dev and a little bit of iOS. Is it a good idea to switch to Flutter or React Native? If you're good in native development in either Android and iOS, and you can pick the other one a little bit, then I would say there is no point spending time on any hybrid framework, because today the demands for native Android and native iOS developer is going through the roof. Hard to find good people, at least at senior positions. It's very, very hard. Hiring for native Android developers, good quality, used to always be a challenge for me. Hybrid apps have their place, but even at scale in big companies where hybrid apps are also used, companies which rely on Flutter or React Native, they would have quite a few people on their teams who would be working on native as well, because they need to do bunch of the stuff in the app in native and sort of glue it into their hybrid code. And hybrid code is still sort of getting used in some startups a little bit. Agencies use them a lot, where the engineering of the app is not so important. It's like more content based apps are getting made, like a app for a conference. So for that, it's a more visual kind of an app, not a lot of deep down native stuff happening. You can make it in Flutter, that's fine. But if you take the top 20 apps on the App Store for both Android and iOS, right? A top 20 in terms of downloads or top 20 in terms of trending or anything, you will find 90% of them are native apps. There will be rare conditions like Instagram is there because obviously Facebook their own framework React Native they're using. I find Instagram on Android, by the way, quite buggy. In fact, there are a lot of places where there are some bugs. On iOS, it's a great app, by the way. But that's how React Native is designed. React Native was originally designed to work well with iOS. Android support they added much later, which shows up in even their own app, I've seen. So, native Android, if you're doing well, and then iOS you're able to pick up, then I think you can stick with those things. That would be best.
All right. Thank you so much, Arnav, for taking time, and thank you so much. Hello, hi, and welcome to our podcast on senior versus junior developer. We'll be doing such live events quite often now. And the topic for today is how do we debug issues in production. But before going ahead, let's take a moment to introduce ourselves. I'm Mohit Yadav, and I teach at SCALER. I've been a part of engineering teams at Hotstar and Nutanix. I was a senior developer in both the teams, and I let Pragya introduce himself as well.
Right, so I am Pragya. You might have seen me on the SCALER YouTube channel quite a lot. And I have been working I had worked at DirectEye in the past, Media.net branch of it. And since the past couple of years, I have been a senior software engineer here at SCALER. So nice to meet you, everyone. I think we can begin it now.
So let me set the premise, right, or what this session is about, and how we are going to be running this session, right? Beginning of the session, we will give you the entire glimpse of how do you debug an application in the production environment, and then we'll give you a chance to ask live questions, right? So keep your questions ready. We'll give you ample amount of time at the end to ask questions. So the premise goes like this. Let's say you have built a paid application that is supposed to stream live cricket matches. Now the match starts at 8 p.m. and 5 minutes into the game, your social media teams comes up to you and says that, hey, lot of paid customers are complaining about poor experience on social media, right? They might be ranting about it on Twitter or maybe Facebook groups or maybe tons of other places to rant about, right? Now, as an engineer who is responsible for streaming this match live to millions of users worldwide, what would be your next steps? I let Pragya talk about the three pieces that we can solve for, and then we'll get started. Pragya, over to you.
Yes. So if you look at any large-scale application, right, any web service, anything like Google or Amazon, or any sort of cricket streaming website that you see, you usually can divide the entire thing into three parts. right? One is what you have is the client side, right? That is the actual user that is sitting there, and I mean they are streaming some let's say cricket matches, right? The user has their browser, they have their browser cache, they are talking to a DNS, and so on and so forth. Apart from that, you have something called the infrastructure, right? And that is basically where your code is running. So perhaps, let's say the website is deployed on something like AWS. So the infrastructure in that case will be the AWS web servers, right? On which your entire code will be running. Everything, the load balancer, the app servers will be over there. And the final side, the last piece of the puzzle for us is the server side. Right? By the server side, I mean that the actual code that is running on the infrastructure. Right? So the actual code that you have written, perhaps in the language using Java, perhaps using a framework like Spring Boot, right? That is what we are talking about. That is the server side. Now, out of these three pieces, we won't really be talking about the client and infrastructure in today's session. Right? We'll be focusing particularly on the server side. That suppose that you have figured out that the problem is not on the client side and neither in the infrastructure. The problem is at an API level. Then how do you debug it in production? Right. So one thing that we can say is, let us suppose that we wish to figure out that what exactly is the problem that our users are facing. Right. So one thing that we could say is that, I mean, let's say that I was on call on the duty. Right. So what I would like to do is I would like to ask our users, right, to report their problems via Twitter messages. So I would ask the users that, hey, just send me a Twitter message, just send us a Twitter message, and basically we'll try to figure out what the problem is and proceed from there. So how does that sound?
I think that sounds good, but there are few problems with it, right? Like you're collecting the feedback that is outside the realm of your application, and that might lead to what we call as a snowball effect. Now, what is a snowball effect? If you notice at avalanche, it starts from a snow which starts rolling down, and sooner or later it becomes an avalanche if there is enough snowfall, right? The same behavior we see in the application side as well. The more people read it, the more negative publicity your application will get. And eventually, people who are getting even a decent stream will start complaining. For example, a person who is supposed to get maybe a 720p kind of a resolution is getting a lower resolution, maybe around 320p or 480p, which is still manageable. They'll also start feeling left out, and they'll also start ranting about your application on Twitter, which is not an ideal case for any business. So can we do something to contain this fire within the realm of your application?
Fair enough. So we don't really want to publicize this issue. So Twitter messages are a no-go in that case. So what we could do is, while designing our application itself, right? While designing the application, what we could have is we could have some sort of a support infrastructure, some sort of support feature inbuilt with our application. Right. Once we have that, then the users can contact us via that support feature directly, and that will also help us to identify whether the problem is on our end or whether the problem is on the client end.
Oh, that's great, man. I think you are also referring to if you have heard about Uber app support, right? They all they have is an in-app support. The benefit that we get out of it is like it contains the fire within the application. Plus, it will help us capture other insights as well, and like deeper insights like network speed, how much free memory was there in the application when this bug occurred, or is there a storage limitation on the client side due to which it is causing such issues. So we'll be able to dig deeper into the issue because a person who's just using your application might not be have the entire context about the problem. And we can capture such problems using a client-side SDK, and we can also use the same SDK to capture all any crash reports, and we can bundle these crash reports and send it to our backend servers. Right? Many times we notice that there are API changes which are not backward compatible, and these leads to errors and exceptions. The responsibility, the person who's designing this framework, he should take care of capturing such exceptions and maybe bundling them and then giving it back to backend servers. And this will, the reason I'm saying this is that it will give an insight to all the iOS and Android teams that I have, and it will tell them exactly what kind of issues their users are facing.
Fair enough. So perhaps using this information, I will be able to, I think, narrow down whether the problem is on the client side or whether the problem is on the server side. But currently, as we said, that we are not going to be discussing about the client side issues right now, or the infrastructure issues. We will cover them perhaps in some of the other sessions. So let us just say that it is not a client side issue right now. Okay, so I have identified that it is a server side issue. Now, what I think I will do is that I will start checking I will start monitoring the dashboards, right, to see if the HTTP responses that our website is producing are those mostly 2xx responses, right? So the 200 responses, basically, that the responses are succeeding. We're not getting server errors from our side, right? Similarly, if the number of 5xx errors on our system is more than a particular threshold, then what we could do is we could raise an alarm, right? That would alert the team and whoever engineer is on the all-call duty. So basically, something like, so imagine if you have if you are working for a large company, then usually whenever a system is live, whenever something critical is happening, something like a cricket match is being streamed, or something like on Flipkart, there's a big billion day going on, then there will be a couple of engineers who will be on call. Their responsibility will be to take care of production issues as and when they occur. Right. So let us suppose that, what we could do is, based on the error thresholds, we could raise an alert and basically get the on-call engineers to respond to it. How does that sound?
It sounds really awesome. You've raised really good points, Pragya. I'll talk about each of them one by one, right? So first point that you raised was around monitoring dashboard, right? Basically keeping an eye on the number of, or basically a percentage of requests that are failing. And we can define a threshold which can be different for each and every system, right? For example, if you're using Google search, the threshold of number of requests that can fail will be very, very low, right? The uptime or the kind of guarantees that Google provide is that their systems are able to respond to 99.999% of the times. But if we compare it with other system like payment system, for example, this number of failing requests is a frequent scenario in such kind of systems. The industry standard for payments getting succeeded is around 70%. They make it to 90%. They go to 90% by having multiple other mechanisms like retries and retries with exponential backoff to make it more reliable. But 70% is basically the industry average. And just by measuring the number of requests that are failing, that will not give me a very good insight as well. What we should typically do is we should also look at how much time how much time my 2xx request is taking. This is usually called the latency of application server. How much time does my application server take to, first of all, accept a request, do all the processing and computing that is required to answer this query, and finally respond it back to the server. The total time in this process is basically called the latency of the system, of the application server. And the reason I'm stressing on the latency part is, whenever you're designing system, the latency also is also quite important. For example, if you're designing a Google search, type ahead, and if that suggestion that comes up, right, when you type Michael, it shows Michael Jordan and bunch of other suggestions as well, right? If you type Donald, it might suggest you Donald Trump or maybe Donald Duck. But the essence of this is basically that these suggestions are only meaningful if the latency of such systems is very low. If it takes 5 seconds to show up these results, it's quite pointless. However, if there is a banking transaction, or maybe you are generating movie recommendations for users who have just signed up on Netflix for the first time, 5 seconds over there is still bearable. You can still bear 5 seconds. They'll wait for the 5 seconds. And hence, I'm saying it again, measuring this time and setting a proper threshold is not only important, but is also use case dependent, right? So this was basically the first point that you spoke about monitoring. Let me give an idea about the second point that you pointed out, which was around alerting, right? So you said that if there is a threshold breach, we'll raise an alert, and that might go to a on-call person, right? But the question is, should we is it fair to wake up a real person post midnight, even if he encountered just one violation of latency?
Fair enough.
The
That
answer,
would be good. Oh.
yeah. So I think that's a rhetorical question. The answer for the question is basically no. It does not make sense to do that, and it does not make sense to do raise an alert for every every sort of exception that we are getting. So we should have basically varying levels of severity. Because I don't want to disturb the developers who are in a case where I'm getting huge number of 4xx, which are basically client errors. Maybe the client itself is sending me a bad request. They're calling a get API, but in the HTTP method, they're writing a post API. In that case, I don't want to alert my developer. So it also depends upon whether the alert that I'm getting is worthy of waking up a person or not. So it should have basically varying level of severity. But I want to hear your suggestions on what should be the criteria for raising an alert in case of specifically in case of latencies.
Fair enough. Fair enough. So what we can do is, since we don't want to overwhelm the person on call, what we could do is we could raise an alert only if the average latency of, let's say, 5 minutes, the past 5 minutes, if that average latency goes beyond a threshold, only then we will raise the alert. How does that sound?
So you are in the right direction, but not quite there. So I'll tell you where you are right. So the idea where you said that I'll use a certain time period for analysis, that is actually correct, right? It makes sense to observe the system behavior for a given period of time, but it does not make sense to use average as a metric, right? The reason I'll come to the reason in a bit, but before that, I would like to highlight over here that you should almost never rely on average metrics when it comes to raising alerts. Instead, what you can rely on is a metric called P99. In simple words, this P99 metric that I'm calling out is that 99% of my requests that are coming to my system will take less time than the time that is reported on against this P99 metric on your dashboard. That means that 99% requests which are reaching my system will, for example, if the time is let's say P99 is written as 10 milliseconds on your dashboard. That means that 99% of my requests will take less than 10 milliseconds. Let me give you an analogy to explain you why average matrices don't work. So the pleasant temperature for a normal human being is, let's say, 25 degrees. Now imagine if I place your head in minus 10 degrees and your feet in 60 degrees. The average temperature is still 25 degrees, right? But it's not a very pleasant experience, and most likely the person will die as well. Similarly, in software engineering, measuring the 99 percentile metrics of P99 are more important as compared to the average metrics. And this is true for any kind of a metric, not just latency, right? We look at other metrics that are quite important. So Pragya, would you like to talk about some of the metrics that are important?
So if I'm looking at the P99 statistic, what I would like to measure is, first of all, the latency of all the APIs that we have in our system. Right. Apart from that, I would like to measure some things about the load on our servers. Right. So I would like to measure how much disk space is remaining on our servers. Right. What is the RAM availability? How much CPU load are they facing? Right. So basically, I mean, based on these metrics, what I will be able to do is I will be able to decide if I want to launch more servers, if I want to scale out, basically. Right, if I want to add or remove instances. And basically what we could also have is, based on these metrics, we could have some sort of a pipeline, we could have some sort of a hook that will auto scale our servers. So if the demand suddenly rushes in and we don't even have a person on call, then the software automatically will detect that, hey, the CPU load is going higher, so it will automatically launch more instances of the application. So latency of APIs, server stats, that is something that I would like to measure. Apart from that, I think at the code level, I would also like to measure the time each function is taking, right? So that would really help me narrow down at a function level, right? Basically where the issue is happening. So it could be the case that basically the call to a particular function is taking very, very long. So if I track the times for each function call, then that will help me pinpoint the issue accurately, right? But I mean, I will have to be kind of cognizant of monitoring the latencies of functions that are involving some sort of IO call, right? So it could be the case that a function is basically making a server request, right? So I mean, I want to measure the latency of functions which are making server requests. But if the function is very simple, right? If the function is as simple as, let's say, add something, then I don't really want to measure the latency of that. So if the function is complicated enough, I would want to measure the time that function is also taking.
So with time, our approach should be that we've started measuring the function latencies. But if, let's say, this code becomes a legacy code and this has been running for like ages now, we should omit the measuring latency part, because that also has an overhead attached to it, right? Because measuring latency, the way it happens is that when a function, when a call comes to a function, the time stamp of that particular that particular timestamp is noted, and whenever the scope of that function finishes, that timestamp is noted, and then difference is calculated, and it is basically logged out to either a log, or it is flushed out to a channel where this latency is basically calculated. So you are wasting three instructions while measuring the latency. So if you have a function like add two numbers, I would rather not measure that particular latency, because I know that this is a simple enough instruction. It does not make sense to add the latency over, measuring the latency overhead in this case. And I'll also like to point out some other parameters that I would like to monitor. Right? I would also want to monitor the amount of how is my heap memory looking at a given point, and how are my GC cycles happening. Right? We all know that most of the programming languages, unless you are writing code in C or C++, comes up with the concept of heap, and they also have a garbage collector, which collects the objects from the heap, right? Frees up the space for newer objects. Monitoring these will give you deeper insights on how objects are basically piled up in the heap, and it may also point out possible memory leaks that are there in your application. How you are going to find out that there are memory leaks? You can just look at the graph of heap memory, right? It will be in a form of a mountain, then a valley, then basically down, peak and down, peak and down. That downward is basically when the GC starts triggering it. So just by measuring this, just by monitoring your heap memory, also you can find deeper insights into your application, and inform your developers that, hey, this is maybe there are some memory leaks in your application. The second one is the second metric that I would want to add is basically keeping an eye on the number of active threads or connection that my application is making. This will give insights if we can parallelize tasks in the applications or not. And the last point that I want to add is around file descriptors. I don't know if you know about file descriptors or not, but file descriptors are basically opened whenever you open up a file on the OS, right? You might have seen. So just go back and do this experiment in any programming language. Open a file, write a for loop, open up and in that for loop, it should be an infinite for loop. Don't do anything, just do try opening files in that particular for loop. Eventually, there is a limit on the number of files that can be opened in an OS operating system, and that limit will be hit and you'll get an error. So there are systems which are basically based on the file descriptors as well, right? For example, Kafka. If the number of file descriptors are quickly increasing, and they are on its way to eat up all the file descriptors that can be basically the OS limit, then it does make sense to raise an alarm to the platform team and alert them that, hey, this is the kind of issue that we are fixing. You might want to do something about this particular issue, right? And using these metrics, we can decide around allocating or removing resources that Pragya has already spoken about. We can scale in or scale out depending upon the load. All of this will basically help me in automated addition of resource or automated removal of resource behind the load balancer. Right? If you have worked on AWS, you will get to know that these are the kind of this auto scaling thing that me and Pragya are basically saying it again and again. Will come up is basically a service that is offered by AWS, and these are the standard parameters based on which you can increase the number of resources.
Cool. That makes a lot of sense. But coming back to the topic, maybe the issue is still not solved. So using these metrics and basically using all these charts and monitoring things, maybe I've figured out what the exact problematic API is, and maybe I have even narrowed it down to a particular function. Right? But I might still not know what the exact issue is. So I am thinking that now is the right time to start looking at the logs, right, and see if we can find something over there. So what I would want to do is I would try to basically look at what servers we have. I would assess it into one of those servers. Right. So I'll just open my terminal. I'll open something like iTerm. I'll assess it into my server. I'll navigate to wherever the logs is located, and I'll just tail that log. Right. I'll try to read the last few lines of that log to see if I can find what the exact issue is. So I mean, what does that sound like?
So if we have multiple, let's say I just have 3-4 servers, so I can use the iTerm window itself to basically broadcast input to multiple servers, and I'll primarily, if I want to just check whether there are exceptions or not, I can also grep for that particular exception keyword into that into the logs, right? But this approach also will not scale, right? Typically, in any company of a decent size or decent volume, those companies have like hundreds and thousands of servers. It is impossible to SSH into each server. So what you can do is you can ask each server to basically direct the logs into a centralized location. Now this centralized location is basically responsible for storing logs from all the services that are there in the ecosystem. So for example, in AWS, there might be, for example, in Amazon, there might be a service corresponding to order management. There will be a service which will be responsible for inventory management, for example. We'll collate logs from all these services, different services, and put it into one place. The benefit that we get out of it is that once we have all the logs from all the services in one place, we can throw all these logs into a system like Elasticsearch, and we can write queries and the same grep command that you are doing on while SSHing into a particular instance. We can do it at a centralized location. I don't have to go into thousands of VMs and find out whether there was an exception or not. But there is still one more problem with this, right? And this problem is not at a log. How do I go into the log and find it out? This is more of a logical problem, right? To give you a glimpse of what this problem is, just imagine how a particular API is written, right? Whenever an API is written, or to write a API, typical structuring of your code is like that. You start from a controller. So your controller is where your APIs are basically defined. From the controller, the request goes to a handler. From the handler, the request will go to a service. From the service, the request will go to a database layer, fetch something, and then return back. Or it might be a case that a service calls another dependent service, which might be a different system altogether, right? An exception can occur in any of the layers that I've just described. Each layer might have different functions, right? The crux of the problem that I'm getting to is that exception can occur in any of the functions, right? And the entire context of the request lies in the controller. How do I pass this context, the complete context which was there in the controller, to the function in which the exception occurred? One way to do that is that I pass the exact request params that are passed during my API call to every function. right? I can create an object of everything that is there in my application, like everything that was passed to my API controller, pass this particular object to each function that is responsible for processing this particular request. But this is far from ideal, right? What if each layer is developed by a different set of teams or different developers? How do I avoid manual errors? Let's say I forget to pass this outside of my service, and the exception was occurring in the database layer. Now, if I forget passing this particular, request to any of the functions, I am the subsequent function calls will not have context about the exact request that was there. So, can we do better than this? A slightly better way to do this is generate a unique ID as soon as I get a request and pass this unique ID in all the functions. This way, I'm not passing the entire big request object. I'm just passing a string. Maybe I can generate a UUID out of it, and I'm just passing a UUID. However, even this approach is prone to manual error, like manual errors, right? So, a common practice to avoid this kind of a thing is, uh, and this is where this basically works because we want everybody to each function basically to follow this kind of a practice that while logging, I'm logging this particular unique ID that I generated in the beginning of the API call. So there is a chance to externalize this responsibility to a framework. In Java world, it is called AOP, aspect-oriented programming. I don't know if you guys have heard about it. This is called aspect-oriented programming, where this aspect will be attached to each and every function, and the responsibility of this aspect is to pass on the unique ID that was first generated. Right? There are many logging frameworks that has this kind of a functionality inbuilt. Right? So using this approach, I've solved for the problem of issues arising within that particular application server. But in reality, to process a particular request, we might end up calling multiple services. For example, to render the homepage of Amazon, we might need to render promoted links, like we might want to promote item like OnePlus, maybe a new iPhone that is getting launched. And we also need to show recommended content based on the user's previous order history. So if a service A calls service B, we need a system that will help me trace the request, not just in service A, but also help me in identifying the same request when it goes to system B as well. This kind of a mechanism, which will help me trace requests from one system to another, is basically achieved by something called as a distributed log tracing frameworks. Right? There are frameworks like Sleuth available, which will give you the exact functionality that I've just spoken about. And the way this works is, you might be wondering how would the request, how would I pass the ID which is generated in service A to service B? The way it is done is that I attach this unique ID into the HTTP header. So whenever service A calls service B, it will attach this unique ID in the HTTP headers. Service B will read this HTTP header around the logs. This is called spans. Will read this particular ID and print it the same way service A was printing it. Right. So this is all you need to do to trace an exception that originated from service A and ended in service B, right? So we've touched upon multiple, just in a very, very short time. I'll open up for questions now. If you have any questions around this, please feel free to ask them now.
Right, so over to you guys, the audience. If you have any questions, chat, and we'll be taking those questions. Okay. Cool. So I did see a question pop up on the screen just now, but the question is gone. Yeah. So
is there? Is these stats depend upon platform we use like Node.js or Spring Boot or which one is better in production. So I've massively worked on Spring Boot. Spring Boot have an open source library of cloud utilities, right? We have Sleuth, which works particularly for Java-based Spring Boot applications. But there are open source equivalents as well, right? Which are basically polyglot in nature. So in those cases, it does not matter whether your service A is written in Java or service B is written in Python. Like, it does not matter which language you are using; it will work. People have come up with standards that, hey, for sending this log to the next application, this should be the header name, and all the applications and all the client libraries are built using those standard semantics.
Also, Mohit, I think Rahul's question is a little bit came a little bit earlier. I think he's asking about the statistics, the server statistics that we are measuring. So you told me that we have to measure things like the number of CPU threads that are running, the file descriptors, and I myself wanted to measure the function latencies and API latencies and stuff. So I think Rahul is asking about that. So could you touch upon that, perhaps?
So yes, so I think it makes sense for Node.js application also. At the end of the day, all the application need system resources, right? We need all the application servers will need matrices to rely on. Like, latency is polyglot, right? By the way, polyglot is that your application or your entire ecosystem of applications that you've built is written in using multiple languages. So these latencies and matrices that we spoke about are basically not language dependent, and all the high level languages that are there right now are basically taking care of the memory by themselves. So in one way or the other, they will need to clear out the garbage that is basically collecting. Memory management is done by those languages. So yes, it helps in measuring those. The short answer is yes, it helps to measure this irrespective of what language you're coming from.
Perfect.
I hope I answered your question, Rahul. We'll go to the next question.
So which are the tools used for monitoring thread dumps, heap spaces, and other metrics? So yes, Mohit, could you say something about this?
I'll take this up. So there are multiple tools, both open source. If you are looking for open source framework, there's JProfiler, which you can attach in your one of the servers that is running, which will give you a very detailed view of what all things are happening inside your heap memory. It will just give you a throw up a heap dump. For example, if the heap size is 4 GB, it will throw up a 4 GB heap dump, and you can use some JProfiler to analyze which object is taking the most amount of memory in your to offer other matrices that we spoke about, like latency and all that. That open source version is you can use Grafana or Graphite to basically push out the matrices, and you can use Graphite for plotting out the graphs. The paid version, however, is basically you can use New Relic. There are Datadog. There's a company called Datadog. Those are basically simpler to set up as long as you're willing to pay them a hefty amount. You can use them. Otherwise, you can go for the open source variants.
Cool. So I think we can move on to the next question. Yes.
Can you provide an example of file descriptors? Okay. Can you provide an example of a file descriptor? So I told you, right? In Kafka, so the way Kafka stores its messages is that I have to give some context about Kafka here. That's what I was thinking. So the way Kafka stores its messages is it opens up a file. That file corresponds to a partition, and partition corresponds to a topic. So at the end of the day, all the messages that are coming to Kafka are basically stored in file. And whenever you have to write a particular message to a file, that will be to write a message to a file, you will have to first open a file and then write a message, and then only you will be able to close it. Now, let's suppose the number of partitions are huge. You've created like I'll digress from the current topic if I go into detail. But let's suppose to achieve scalability, what you did was you created multiple partitions of that particular topic. That will end up creating multiple files on the operating systems. And if you start writing to all the topics at one, or all the partitions at a single time, you will face problems of file descriptors exhausting out. I hope that answers your questions, G. How to debug an issue where a set of users are experiencing slowness in global app like Amazon and Netflix? Ratnesh, that is an excellent question, and that comes under the purview of infrastructure piece that we are not covering today. A short answer for that is it might be due to DNS which is getting misconfigured. It is very much possible that, let's say, I am sitting in India, and in the DNS resolution step, what happened was that I was returned an IP address of, let's say, US, right? So that will inherently add a latency of 200 milliseconds because India and US are geographically quite distant from each other. So that's a short answer. We'll do a separate session on the similar lines where we'll dig deeper into the infrastructure issues as well, and client-side issues also, right? For example, if I talk about just one line of about client-side, it is very much possible that the stream that I'm sending to the my client is not compressed. If that is the case, then it will experience a lot of slowness. So those are some kind of client issues. So we'll do a session on both of these in future. Don't worry. Any other questions, guys?
Cool. So I see this one nice question from Jeet. Jeet is asking the following. Can you take this up, perhaps?
Yes. Can you give some tips on how the on-call support engineer should start debugging? Like, should he start from infra exit or heap first? Okay, that's a great question. Let me this will basically give us a chance to summarize our discussion as well, right? So the first thing is identify whether it is a server-side issue, infra-side issue, or is it a backend issue. How you are going to identify that? If the problem is coming to you, chances are it will be a backend issue. That's why we did this problem, right? The way to negate a infra-side issue is monitor on your load balancer. So if you're deployed your application on AWS, AWS load balancer will give you a metric about how many 4xx and 5xx and 2xx are there. If the number of 5xx are alarmingly high, chances are it's a backend issue, right? AWS also gives you a way to monitor how much time each request is taking. So if the latency of a system is going for a toss, that means it's again a backend issue. Using this, you just have identified that, hey, this is the backend issue, right? Then you drill down which API is causing this kind of a problem. Again, the friend over here is your monitoring dashboard. Have a monitoring setup. The way you set up monitoring is either you can go for open source versions where you measure the latency of every API, or you go for a paid version which will do it out of the box for you, right? After you have identified which API is causing the issue, you drill down into that API by using the logs that you are getting logs that you're connecting, right? So using this, you'll basically narrow down the problem to exact issue that exact issue that is basically coming up.
Cool. So I think this is another interesting question that we have.
How do you debug issues when a cluster is running in different regions? So simple answer is that monitoring dashboard will basically define where exactly your application servers are running and which application servers are performing different tasks. So typically how you set up monitoring in those cases is you have different dashboards for different regions. So have a collated view. So I did this in Hotstar as well, which was live in US and India at that time. So we had a separate counter and separate latency metrics for US and a separate latency metrics for, I'm just using latency, but there were a bunch of other matrices as well. We spoke about them in the past. And a bunch of matrices in India data center. The reason we set up a different monitoring on both of them is because the data center, inherent data center, which is serving Indian users and US users, are different, and that's the reason we like both of them will have issues, will report issues separately. Right? It's just that Hotstar.com for US users will resolve to US data center, and Hotstar.com for Indian users will be resolved to India data center.
Perfect, perfect. This seems like a really interesting question. Chahat has a question about low load services.
I provide one error out of 4. Made a certain. Cool. I will give you a very good analogy for this, right? I'll give you a good example where such kind of systems will occur, right? So, assume you're building a Netflix ingestion pipeline. Okay. Ingestion. What an ingestion pipeline means? That let's suppose Netflix comes up with a new show and it wants to air a new episode in that particular series. So that is actually a very time-consuming task as well, right? Typically, it will take hours for a person to upload it and take it live to the end audience. The reason is that it will go to multiple quality checks, both manual and automated. There'll be checks in the frame as well. So the kind of TPS on these kind of systems is very low, and even if one request fails in such kind of scenario, even if one request fails, that means there is a huge amount of customer base which will get impacted. So I should definitely raise an alarm in case there is even a one failure. To avoid waking my on-call engineer on the night, what I can do is, if this is not a fire, depending upon the feature, right? Let's suppose the video that I'm trying to ingest in the Netflix system has to go live next week. I still have time. I will raise an alarm. I will send an alert, but the actual call to the person will go in the morning during the office hours. So those things are, I'll basically change my alerting mechanism, not my monitoring system. Monitoring system still remains intact.
Cool, cool, cool. That makes sense. Ankit is asking, can you talk about some tools that you can use to automate the alerts?
Right. So one of the just explore Elastic Stack, okay, for all these kind of questions, for monitoring, for logging, for distributed tracing, for alerting. Use the ELK stack. That stands for Elasticsearch, Logstash, Kibana. Kibana, the newer version of Kibana especially, has a capability to send alerts as well. For doing an on-call kind of a duty, if you want to manage who is, let's say there are 6 developers in the team, there's one developer from the team takes care of the entire infrastructure for 1 week, and then you rotate among the people who are there. So for doing this specifically, there is a tool called PagerDuty. It's a paid tool that you can use. With PagerDuty, you would be able to call the person, send an SMS, send a pager alert, and do a bunch of other tasks as well.
Interesting. Cool. Jeet has a question about that his company is using P70 matrix instead of P99 matrix.
Wow.
So could you talk something about that?
That's a very so I would say that P70 will not give you good insights. I think maybe the reason why your company is using a P70 kind of a metric is the SLAs are basically defined that way. So typically when you have enterprise contracts, right, you have to define how much would be your P99, P70 or P50. There's a P50 as well. So it starts from P50, P70. 70 is the first time that I'm hearing it. P50 is there, P75 is there, 95 is there, 99 is there, and 99.9 is there. And usually when you have a service level agreement between enterprises, you have to specify that what would be the threshold or the max limit for these metrics, right? So maybe the project that you're working on, the contract was that 70% of my request will, I'll basically please 70% of the customers. But as an engineer, your goal should be to look at P99, or maybe if you are a rockstar engineer, then look at P99.99. You can add as many nines as you want.
Cool, cool. Ratnesh has a really interesting question. Ratnesh is saying that debugging is good, but we should try to avoid the problem in the first place. So, when we are writing the code, what can we do so that debugging becomes a lesser hassle and we can do debugging really fast?
Yes. So if you remember the first thing that I told you, right? If you're an application developer, for example, Android app developer, the exceptions are occurring on the mobile devices and not at the server. So whatever exceptions are occurring on the mobile devices, you won't get a chance to know about them. That's the reason it becomes essential that as soon as an exception is occurred, you log it in the system memory, Android device, right? And from that Android storage, once a person is connected to internet again, send that error report to the backend people, so that they can go and debug that particular application. Uh, for others, right? For backend systems, having a so typically how people do it is, as soon as they get an exception, they keep a monitor on their logs. As soon as they get an exception, or maybe you would have written try catch block if you're a Java developer, right? In the catch block, just put that exception into a queue, right? People call it a dead letter queue. Put that exception into a queue, and there is a special person who can look into what are the exceptions, what are the most common exceptions that are occurring, and you can look into that. Paid solutions for logging exceptions and doing all these exception analytics is Sentry and Crashlytics. I think they have they also have an open source variant or a community edition. I'm not sure about that. Just go and have a look at whether they are providing a community edition. But paid solutions are already there.
Cool, that is interesting. I am not seeing any more questions in the chat as of now. So, guys, if you have any more questions, please keep them coming.
Yeah.
Okay. So we'll just
You
wait
can-
for a couple of minutes.
You can, or what you can do is, you can even after the session is ended, put your question in the comment, right? That will help us. We keep on looking at the comments, and we'll reply back if you have any questions. Also, I would request everyone to please comment about specific areas that you liked about the video. That gives us encouragement and motivation about doing such sessions in the future as well. And please like, comment, and share and subscribe to our channel. Grow and spread this word. This is a free initiative that we have recently started, where we will help in helping each and every engineer grow and upskill themselves. So please do like, comment, and share and subscribe to our channel. Yeah. Sunil has a question. I'll take this as a last question. How to handle garbage collection in time of multiple tigs or threads? So garbage collections are specifically for Java. You have special collectors that you can have. You can configure the kind of collector that is running. There is G1 GC, there is serial collector, there is parallel GC, there is concurrent mark and sweep. So multiple algorithms are there for garbage collection. For others as well, I think Pragya can talk about if you want to talk about some how does GC works in Python, and if you can configure a garbage collection algorithm.
Right. So I'm not sure. Python does allow you to hook into the GC. So I think the library for these are inbuilt libraries in Python, which is literally called GC, right? And you can basically hook into it to figure out when an object is being garbage collected. I think you can plug and play different algorithms in there as well, but I'm not exactly sure. You will have to check that library. But if you look at any sort of programming language that is used for web services and that has some sort of a garbage collector, you will be able to that programming language will definitely support a library to hook into garbage collector and basically try to configure. You can try to configure basically when the garbage collection happens or what algorithm the garbage collection use. You can basically tweak those things. Does that make sense? I'm not sure if that answers your question. So your question is more specifically how to handle garbage collection in time of multiple pings or threads. Is that your question? Multiple pings or threads?
I think it's multiple things. Okay. So you cannot control garbage collection. You cannot say to the garbage collection that start collecting the garbage now. You can, however, hint it, and it depends upon the algorithm that you're using. It might honor your request or it might reject your request as well. So there's nothing special that you can do in terms of that I want to collect the garbage now. That is not possible. Even in
So
Java.
one thing that you have to take care of from a design perspective is that, you have to look at how your application is managing the objects. In case your objects are forming a very large graph, right? If they're forming a large cyclic graph of objects that are dependent on just one variable, right? So imagine that there is one variable that is talking to an object that is basically referring to an object, and that object in turn is referring to an entire tree or an entire graph of objects. Now, if this variable goes out of scope, what will happen is the garbage collector will kick in very late to clear up this entire graph, right? So you should try to make your design in such a manner that this thing does not happen. Does that make sense? So that is something that you can do. Now, of course, for garbage collection, there's a lot of other things that you can do. So perhaps what we can do is we can have a separate session on that sometime on the
I think
Scale channel.
there are multiple people who are requesting for a session on garbage collection. So we'll probably plan a session alongside, after we are done with infrastructure and client, we'll probably plan a session around garbage collection as well. Cool. Keep the interesting suggestions. When if you have any suggestions around what topic we need to do, please comment that topic name, just the topic name in the comment. We'll make sure that we do a session on that one. All right. I hope the session was informative and interesting for you, and I'll hope to see everyone in the next session.
Perfect.
you
So
so
one more thing that I would like to mention, Mohit. So apart from this particular session, in this junior developer versus senior developer theme that we are having, what other future videos are we expecting to see? Can you comment something about upon that?
So we'll have a video. So next we are planning to have is a session on. So this was basically a tech-oriented session, right? And technical skills is not the only thing that is required to climb up the ladder. So we are planning to have a session on soft skills. You won't believe the differentiating criteria between my interview at Facebook was basically on the soft skills aspect, right? So they say that the technical interviews are basically a filter criteria, and whether you'll be offered a position as SD3 or SD2 depends upon how you portray yourself in the team and how do you manage team, right? Manage your team. So we are planning to have a session on soft skills specifically, probably next time. And we're also, again, we missed out on the client and infrastructure side. So we'll also have a session on that. We'll have sessions on how do you develop a app, like roadmap series kind of a session. How do you develop an app from start to the end? So those are the things that are there in the pipeline. Hope to
Perfect. That sounds interesting. So, as we said, guys, keep the questions coming. Basically, we will be ending the session, but we'll be monitoring the comments that you are posting, and basically, if you have an interesting question, we'll be replying to that. All right.
Yeah.
So that is it for this session. Hope to see you guys in the next session. All right. There are many more to do. So see you then. All right. Bye bye.
Bye bye.